I see you. Hello, Alec. How are you doing today? What did I do with that roll of plastic? I gotta find that. Hello, Astro Printer and Alan. Having a good time with it, huh, Astro Printer? So far, I've been pretty impressed. I made a big one of those little storage drawers that fold up, and it came out quite nice. I shouldn't have used the silk filament. That was a mistake. But still, I'm very pleased with it. Where'd the other piece go? There it is. Yeah, there's one of those folding crates. And it came out quite nice. So today I figure we'll dabble with the high temperature hothead. And then the whole thing folds down. I've been printing a lot of these. I like them. Boy, one of my old digital cameras came with yeah, it breaks easily. You can see it when I open it, it cracks right there. See? We're gonna print with carbon reinforced polycarbonate. One of my old digital cameras, I found a bunch of 2 megabyte compact flash cards. Boy, how often do you see stuff like that? That's enough for this antique to take 2 pictures, maybe 1. This was surprisingly good for an antique camera. I wish I'd have had one back in 1997. It would have been amazing. Oh, because 2 megapixels and an 8 times optical zoom. Not bad. It also has the ability to do video clips, although no audio, I don't think. I think it's just video. And it's like 16 seconds. Very hard, lame quality video. But it could do pre-video. So it's always capturing video, and you press a button and it captures the video before you press the button. Pretty cool. And then this is similar to one of the cameras I did used to have. These are antiques. These are all from the late 90s. I actually had the original version of this, the QV10A. Cost me $700 to buy that thing, and it recorded out 640 by 480 pictures. But this one had a nice, neat feature where it could pre-capture. So it would take 4 pictures in rapid succession, but it had the ability to cycle through. So when you pressed the button, it saved the 4 pictures before you press the button, which solved the problem of these cameras being slow. You know, you'd press the button and like a second and a half later it would actually do something. So with this, it was constantly taking pictures, and then when you finally press the button, it saved the 4 frames before you press the button. So like an early version of precognition. And it's kind of interesting because Casio really went far with that in future cameras. I never realized they had that precog functionality in their early cameras. That's called a Mavica. That's from Sony, the Sony Mavica. And it saved pictures to floppy disks. Because at the time, it was a convenient storage medium. It was everywhere. And then you have modern toy cameras like this that are actually kind of cool. It's good. So this is really interesting. I mean, it's a toy camera. There's no question it's a toy camera, but it's a shockingly interesting toy camera considering. You know, it's a USB charge, of course. It's got an LCD screen, but this one is a microscope and a telescope, basically. So one camera is for real up close work, so you get real close and it's like a microscope, and the other camera is no enclosure. That's why we're gonna stay small. So that's kind of interesting. It's an interesting camera, but no zoom capabilities. So you got a fixed telescope or you got a fixed microscope. But pretty cool. I like weird cameras. And so where is that roll of filament that I had on the ground here?
Is it a white box?
Yes. Oh, that's probably it. Because you got me that pry line box.
3D?
Yeah. That's probably exactly it.
Oh.
Hi, kitty. Yeah, he knows you're getting ready to feed him. Yep, he knows you're getting ready to feed him. Carbon fiber polycarbonate, yes. From Pryline. Hey, Maker Viking.
Maybe sit down, Chris.
I know an enclosure is ideal, but I'm going to gamble. You don't want BPA? Oh, I don't care. I have so much ventilation, I'm not worried about that. But I'm going to take a gamble that I can get away without an enclosure. What the hell is this shit made of? I can't cut it. That's some impressive stuff. Hi, baby.
Yeah, both of them.
Pygar says hello. Pygar.
Hi. Me?
Bite me? Why would you say that to him?
I didn't. I said hi. Smart ass. Smart Alex.
Where are... I just had tissues that I put aside specifically for the stream, and they're gone. Oh, here they are.
Duh.
So I gotta blow my friggin' nose.
Oh,
These are weird, like, hard, like, tissues. They're weird.
From Domino's?
Ooh, is that blood? No.
After I feed them, I'm going back to my room.
Mm-hmm. Did I take that off with you?
I'll leave it on the table.
And you left the creamer out last night. I had to put it away.
I did?
Yeah, you did get punished for that.
Sorry.
Yes, they sent me... they basically just ordered one off Amazon and sent it to me, which was nice of them. And it works pretty well. Hopefully, they'll use something like this with the actual shipping printer. No, most likely what's Rick Standen said he bought a CTC CR10S copy. Most likely, if the nozzle only goes to 195, that would imply something's wrong. But the bed going to 50 might simply be that it's just not powerful enough. Like it might be inadequate power supply, where it just can't draw enough power to get it hot. That would be my first assumption with those low temperatures, because that's a really low temperature. Wow, this feels nice. It's got a very rough, matte feeling to it. So it says temperature 250, 260. We're going to go a little hotter than that. Bed 80 to 110. So that is within range of our hardware. Seriously? Seriously? That's how you're gonna play this? That's how you're gonna play this, huh? I'll kick your ass. It's trying to unspool itself. Yeah, 12 volts gonna be the problem. Yeah, with a heated part of only 100 by 100? Yeah, that's not gonna be fun. That's a PLA machine. That is not going to be fun.
Watch it do it again.
Yeah, it's going to try to do it again. It absolutely is going to try to do it again.
It doesn't like you.
It's going to get its ass kicked.
Watch your mouth.
Make me.
You're not allowed to do that on the stream.
So we got to pop this head unit off, and we're going to put the high temperature unit on. So you're probably, what I would probably do is not even bother try upgrading that machine to print better temperatures, because by the time you put the money into it to print at higher temperatures, you'll have put enough money into it to have bought a higher temperature machine. However, $20 for a better heat bed's not bad, as long as the bolt pattern matches up. Might be better off just leaving it as a PLA machine. And then put that money toward a different machine if you want to do something different. Don't you mess with me. I will bite you. I want to get that new Creality hot end on Amazon for $50 that I can go to 500 degrees.
Come on.
Wow, that's not bad. Okay. Jacked, plugged and loaded. Now, this needs to go over top like that. Okay, the only problem with putting the spool holder on the back side is it really wants to pull this really springy filament like this. It really wants to pull it off the spool. Like it wants to yank, it wants to unspool from this thing so badly. That's because of the filament. It's very springy. But once it, see how it's trying to unspool itself, and what happens is it wraps around the shaft when it does that, which is really, really bad. You don't want that happening. Okay. So what I might do is actually put a bar between the two spool holders to stop this filament from trying to do exactly. Well, I am telling you this, and you can't see what I'm trying to show you. So this filament really, really, really wants to unspool itself. See how it's trying to unspool itself sideways? It's because the filament's really, really springy. And, you know, you just touch it wrong, and it starts unspooling itself like that. That will cause a jam while you're printing. Yeah, look at this. It's undoing itself. And that's because this filament is real springy. But if I had a bar going across here like this to stop that from happening, maybe. That, or they're going to need much, much taller spool holders. They're going to need to raise the height of these spool holders like 100 millimeters. Because otherwise, you're really limited to like 300 millimeter of build volume. Because if you go to 350, these heads are going to crash into the spools themselves. And you're not going to want that. Okay, so new heads attached. Filament is ostensibly loaded. X1 is nice.
Thanks for getting me in that.
DeWitt says hello.
I see that. Because you got me in the picture when you were showing.
Don't worry about the ugly troll.
You're the biggest ugly troll.
I'm an evil, dangerous troll.
That doesn't sound right.
It's just, god damn it, the spool does not want to stay spooled. Like, it really wants to unspool itself.
It's messing with you.
So, you know, I need an arm that actually grabs the end of the spool so that the filament cannot unwind onto itself.
Hi.
Alright, let's slice up one of those screws. Don't need that. No, we're not going to print that. I don't need that. Let's create a Cfpc profile. Let's leave all those settings like they are. Let's leave those settings like they are. I guess the only thing we really need to muck around with is temperature. We need to change to the MakerPi. Let's go 85 on the bed and 275. Let's start with 275 on the extruder. Oh, does it? I don't think mine came with those parts. It did come with some Bowden tube. I think this came with the printer. And it also came with some little lockdowns. This is actually what was giving me the idea, but having this come out sideways instead of forward. So it came with these little grab holds for the spool itself. That would actually help keep it from, partially keep it from doing what it's doing. Because it won't let it wrap fully around. Oh, I gotta stand up for this. Oh, small. That one. Seriously? Seriously? God damn it. It really likes messing with me. Oh, I think I see what you mean. Because I see a hole where that Bowden tube could go. Yeah, I think I see what you mean. And I don't need much. Just enough to go to 90 degrees. Just enough to give me entry point control. And we're going to reverse this to go this way. That's not going to stop it from doing that, but it will help control it. See, it still wants to flip over. What the problem with this is it's so springy that it wants to pop up and over. Boy, that applies a lot of drag. I think it'll be fine, but it stops the rollback. That's not going to stop the problem, but it does really help alleviate it, especially if you set it up properly. So what I got is this here. So I set that up right there like that. So now the spool can unspool into the piece of Bowden tube here, and then that'll just sit in the open air like that. And that will it doesn't stop it from, if it comes loose, it's still going to pop over the spool. But the biggest reason that happens is because of back roll on the spool. So when the spool is rolling and then it goes backwards, that's when the filament pops off. This provides enough drag that that's not going to happen. That's going to hold the tension on that spool, so it should stop that problem. That is pretty smart of them. I like that.
Here first. In case you need them.
Thank you.
I fed the kitties.
Yeah, that's actually pretty neat. I like that. They really need to fix the spool holder though, because the spool holder's loose. I can temporarily fix that with a shim. I just saw a piece of zip tie. That would probably fix that pretty nicely, temporarily at least. Not quite. It's actually the right thickness, but I'd have to loosen it to get it to fit in there. Mine's very loose. So the bolts they used were a little too long. So my spool holders go bub 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 bub. They wobble because I can't tighten them down all the way. The bolts that go through the hammer nuts, they're too big. So they bottom out in the profile before they tighten up on the holder. What I want is an Ender 5 with a conveyor belt for the bed. That's what I want. I want an Ender 5, so the X and Y axis are independent of the Z, and then I want the bed replaced with a conveyor belt. This way, instead of printing at 45 degrees for continuous length, instead I can print normally, and then when it's done, rotate the bed to a new section and then make the print again and again and again. Basically, I want to be able to print the same part over and over again. That'll really, really come in handy for doing things like these little fins. Because I tried to design these fins for 45 degree printing, doesn't work as well. But these print very well in regular vase mode printing. And so I could print, advance, print, advance, print, advance, print, advance, and I can just tell this thing to print, 500 fins. That's what I want. But I understand one of the reasons they're doing the 45 degree is to get around the stupid patent that exists on that. Even though that patent shouldn't be allowed. There's plenty of prior art. Okay. Primitive profile is set up. Where would the screw be? Downloads, screw. That is so not what I wanted you to do. And I can't... How about just show me the goddamn file? Thank you. Stop being a punk. Grr. Okay, let's make it 150 tall. Let's rotate it 180 on the axis. There we go. Okay, let's try it. I just hate when it does stupid things. Like I type in the name of the file I want to find. It shows me the results in a drop-down list. I don't want an effing drop-down list because I can't drag and drop from the drop-down list to put it in the program I'm working on. So all you can do is click on it, which tries to open it, which you don't want to do because you already have your program open. Urgh. It's like this is something that, it should have been thought of. The very first time they tried to use it, they should have thought of it. Either make it show up simultaneously as a search result. You have to actually press enter to make it show up as a search result. And, or make it so you can drag and drop from the drop-down list. Alright, so we're going to do 0.24 layers at the beginning because I want to be nice and thick. Tools variable. Let's do the first millimeter. Yes. Actually, it has to be first 0.96. And split process. So we're going to do a nice strong base with 4 walls, 3 top and bottom. Then we're going to switch to vase mode with a 1.6 extrusion multiplier. Actually, probably be better if I just tell it to extrude 0.65. What's up, Mike? And now we're going to go down to 1, 0, and 0. And we're going to go down to 0.1 layer height because we got to be able to handle the curves. So that'll give us a nice strong base. We are going to add a brim. Make it 0 and 10 loops. And then we're going to ramp up the temperature to 285. We're going to keep the speed at 50. I think that'll do it. The speed won't really matter because the printer's going to run slower than that no matter what we do. I also want to change the Z height to be like 180 to extend those screws a little bit taller. The increased angle will be better for vase mode. It'll make a less shallow horizontal deviation. So we'll just stretch out the screw a tiny bit. That should do it. I think that'll do it. Let's try it. Alright, the audio should be back now. I wish I knew why it was random. Like, it's totally random when that happens. Yeah, to get the audio back, I have to close OBS and reopen OBS. And that is not the setting I picked. That's because I did it on this one. We need this one. 0, 10. There's a delay now? Seriously? That might just be you haven't hit refresh. Since, well, why is the... Is my processor? No, 9%. Seems like there's a little bit of jitter in the video. What the fuck could cause that? How about now? Okay. I just rebooted OBS again. That's weird. That is weird. Okay. see. Oh, I think I did a sequential. I want to do continuous. There we go. Hello. Okay, that looks good. There's no reason that should take 5 hours. Hopefully that's not accurate. I think we better shrink this a little bit. And what's gone again? Are you telling me the audio's gone again, or is that a sync again? Alright, let's try saving that. Deck screw, high temperature. What the fuck would make it out of sync 10 seconds? 10 seconds ludicrous. That's not something on my end if it's 10 seconds. I mean, is this better? Alright, let's try not switching windows. You know, that shouldn't do a damn thing. Hate when this stuff doesn't work right. Makes me want to growl. Okay, exported. Wow, that was a relay that sounded like it clunked. And that fan's dying. Oh, I didn't tell it to... use the correct extruder. If you can get them to send me one, they got to send me one for me to review it. Okay, so this needs to go to secondary extruder. How do I make it use the secondary extruder? So that'd be tool 1, right? I think I just need to pick tool 1. Well, because they're direct drive. So they have to be modular. So this is the part that connects to the printer itself. And then there's your hot end. And there's your stepper motor, and your feeder unit is in here. So this is the flexible drive unit. So really, there's not much in here. This is just a shell. There's actually not much inside that shell besides, you know, your hot end, your fans. So it looks bigger than it is. They are pretty heavy. because, you know, well, it is got this mounting block and it's got the stepper motor. But in reality, that's more to keep them all the same. They all look the same. So I think I pick tool 1, I think. So I think I changed that to tool 1. And change this to tool 1. No, that stays T0. This changes to tool 1. I think. It's been a while since I did multi-extruder on a printer like this. And that is exported. Normally I preheat both, but I'm going to let this one go on its own because I want to see if it heats up the correct tool head on its own. I wonder why invoking a window causes it to do that. You know what I wouldn't mind seeing? I wouldn't mind seeing a an Ender 5 with a 150 by 150 by 200 build volume. That'd be pretty cool, actually. You know, but shrink everything down. Use smaller extrusions, smaller wheels. If those parts exist, I don't know. Basically an Ender 2, but in an Ender 5 form factor. You know, something real strong, cube-like, using linear rails instead of the wheels to keep everything on the inside. A Voron 0.1, huh? Oh, wow, it does look pretty small. But how big is that? Like, I have no... See, I wouldn't even do that with the spool holder. I'd lay the spool holder on top. That is pretty cool. Yeah, I figure as much. Yeah, this kit is $453. 250, 250, 400. Yeah, it's a big build volume, so it's going to be a pretty big printer. That's actually a large printer. That's going to be bigger than the Ender 5. In order to have a 250 by 250 by 400 build volume, it's going to have to be bigger. I might have to look into building something like that. I mean, I can't afford it right now. I don't have the money, but... Yeah, I did look up the Voron 0.1. It was very cool looking, but very expensive. But I'm thinking, I guess I could do the whole thing out of 2020 rail. 2020 rail is pretty skinny. Huh. I might have to look into that. Well, what I want is a little printer that can print most of the parts that I need to print, but that's, you know, relatively quick. I want a cube structure for strength, something I could toss in the car, take with me. Basically, I want a more rugged Ender 2. The Ender 2 is perfect in size. I mean, it's perfect. The problem with the Ender 2 is it's not rugged. Well, I'm only using 7%. 10% CPU cycle, so that shouldn't be causing a problem, but I can do that too. I mean, this is a modern core i5, so it shouldn't be having any problems. OBS. I can't change the priority of apps anymore in Windows 10. It looks like I can't change the priority of tasks anymore. The veneer. The veneer doesn't do me any good. Do you have more details? I find veneer 3D models. Yeah, which one?
I am Groot.
There's only one sub menu. And that's resource values, and all I can do is change percent and values. I have no option to adjust priority. Hey, I got the right head. Oop, I forgot. Oh, I just broke it. God damn it. Oh, this is going to be fun. Seriously? Well, I think And where the hell is my flashlight? How did I lose that flashlight already? Oh, you stupid remote. Now we're balling up. Well, it's starting to put down. The filament. I snapped the filament. It is so unbelievably slow. And no Z offset adjustment, which is really freaking annoying. Let's make the first layer height 0%. That'll bring it down as low as I can. Oh, you have to go to detail screen first. That's annoying as fuck. Why would they do that? And then I can go to set priority. But I set it up in OBS and that appears to have set it up here. And Maker Gear is very expensive. Wow. Wow. That sounds pretty cool. Hello, Matt. No Amazon link, no. Okay. Yeah, they filter links. Oh, wow. Good for you. A little bit of recycling arbitrage. Hell yeah. You'll have to email me or message me on Facebook for the link, since YouTube is hiding it. Hi, baby. Hi. Yeah. Grabbed a little more money from Google Rewards. Actually, I need that. Why is it so low? Do I need a hotter bed? It does not want to stick to this bed. Oh, I think I got it. Of course, it's black, so it's hard to see. I don't think it's laying down a layer. I can't tell.
Try hotter. I think I'm just making a big blob, is what I think. Ooh, I think I got it. Oh, I think I got it. I think it's laying down a layer. Now, how do I turn off the fan? I don't think I can. Fan speed off. I think it's laying down. Let's see if I can give you guys a view without killing sync. Cross your fingers. Oh, what did I miss? Wow, nice. So you like the CHT nozzle? That's good. Yeah, I think it's laying down now. It sure looks like it is. I had to raise the temperature up to 295 on the nozzle. And 105 on the bed. So I was running too cold. But once I cranked up the temperature, it started to stick. Michelle's in her room. Oh, that first layer was like garbage on here. Can I do a digital zoom? Is there no way to do a zoom? Filter. Nope, that's not what I want. I can do a crop. Okay. There, I think I got it. Now you guys can see a little bit better. Hey, I think it's actually working. There's a big booger there, but it's not part of the model, so we're good. Now let's try changing the print speed. That's fine. Not exactly what I want, but it'll do. At least you can see it. Nice. Yeah, big nozzle printing is fun.
Yeah, for larger models where you don't need the high detail, the bigger nozzles let you print so fast. Oh my god, so fast. .6mm is usually a good compromise. You still get decent resolution, but you get the benefits of the increased volume. Nice thing is this is dry filament. I don't see any signs of bubbling or moisture presence. So that's good. Nice. The only thing I would caution with is for the 0.4mm and maybe the 0.6 as well, is I would not use any fill filament. You know, don't use any carbon or fiberglass or Kevlar or anything like that. Or wood filament or anything with fibers in it. I would avoid that. Now, once you go bigger than 0.6, you should be fine. Okay, so we are going to want to change this to 105 on the bed and 295 on the nozzle. You got it. It depends. The CHT nozzles are made by E3D, and E3D has a history of making very high quality nozzles. So, the engineering on the nozzle is important, because that's going to affect the flow characteristics and whether or not you get laminar flow through the nozzle properly or not. Now, are some of the really expensive nozzles worth it? I don't know. The CHT, yes. That nozzle has been tested, and these nozzles give you, or Bondtech, not E3D, Bondtech. These nozzles give you better than Volcano performance on a regular hot end. Like, you will actually get better flow than a Volcano. That's impressive. CNC Kitchen has some very good videos on the CHT nozzles if you want to see more on that. I did also get those new diamond nozzles. So we will be playing with those in a future video. These are the Diamondback nozzles. So this set is $260. They are not cheap. Are they good? I don't know. We're going to find out. But it looks to me like these use a similar technique to the Ruby nozzles, where it's a brass nozzle with an insert that has the special material. Supposedly it's diamond infused. So here's that nozzle. There we go. You can see there. That's the big one. It looks pretty nice. Only time will tell. Looks like it's got a nice machined edge. You can see it reflecting right there. Look at that. That's a nice edge. So I do look forward to playing with this. So I very much look forward to messing with these nozzles. I believe it's 4, 6, and 8, I think. Or 4, 8, and 1. It might be 0.4, 0.8, and 1 millimeter. I'll have to check. Does it tell me? No, it doesn't. Diamondbacknozzles.com and made in the USA, which I kind of dig. There's a QR code you can scan. Yeah, 0.4, 0.6, and 0.8 millimeter. They are $95 a piece. Keep in mind, I have not used these yet. I love the little case they come in. I do suspect these will have well, this is not for regular printing, okay? That's not what these are for. You're not going to see any difference printing PLA with this nozzle or the stock nozzle that came with your printer, unless the stock nozzle was crap, which it probably isn't. And Prusa doesn't use crap. Prusa uses good materials, so that nozzle will be fine. Now, try to print some glow-in-the-dark filament. Let me know how your nozzle lasts. If you make it through half a roll of filament, I'll be impressed. Glow-in-the-dark filament is some of the most abrasive filament made. It is aggressive and nasty to your nozzle. It tears up brass like it's butter. Carbon fiber and fiberglass infused filaments are similarly aggressive against the nozzle. And so what you need to do is you need to use a hardened nozzle, either a coated nozzle like Nozzle X, or a hardened nozzle like A2 tool steel, or in this case here, like a ruby nozzle with a ruby tip, or this one here with a polycrystalline diamond tip. So that tip is actually, I can show you. They sent a nice little little presentation kit. You can't buy this. This is something they send to reviewers, which I thought was pretty cool. So you know, that's like, apparently that's actually diamonds in there. That's actually diamond powder. Would you autofocus, please? There we go. Tungsten sucks. Tungsten is not a good nozzle. It's indestructible. The problem is it's an insulator. So tungsten is a very poor transfer of heat. I am printing with carbon-infused polycarbonate. So we are printing at 295 degrees Celsius, 105 Celsius on the bed. And so far it's looking pretty good. It's looking really good, actually. So, so for example, the Olsen Ruby nozzles are made of this. They're made of a ruby material. This is what's called lab-grown ruby. And this is lab-grown diamond. And the idea is the material is hard enough that the materials you're printing with can't damage it. So you'll maintain that precision and that same nozzle orifice no matter what you put through the nozzle. That's the idea, at least. And I'll be having a separate video on this
because I'm definitely going to play with these. But the whole idea behind that is now you can print these carbon, fiberglass, wood, and glow-in-the-dark infused filaments without destroying your nozzle. Yeah, sure, nozzles are cheap, but when you add the man hours required to replace that nozzle every time you destroy it, which will be basically after every print, and then the man hours because you messed up the joint in your assembly and have to do it again. Go to Walmart and touch everything. So it'll be interesting. It'll be very interesting. I like that it's USA made, so there's a give me on the price because it's USA made. Labor here is more expensive, so I expect the nozzle to be more expensive. China could probably make these for $50. They also said that they are looking into other uses for the nozzle, and they are considering, no guarantee, this is just something they're considering. They're considering making a acute angle nozzle so that we'll be able to use it on, for example, the CR30. I would love a 1mm diamond tip nozzle for my CR30. That would be amazing. I'd put that on my CR30 immediately. But I really want 1mm, not 0.8. I mean, I'll use 0.8, but I really would prefer a 1mm. But it needs that acute angle so that the nozzle doesn't rub the bed. This looks beautiful. This filament looks absolutely gorgeous. I mean, we could barely see any of it yet, and it looks gorgeous. This is working well, the Bowden setup, so I will give them credit for that. They did a good job on that little Bowden clamp setup. I have no issues. It looks great and it works great. I'm going to have to cut that Bowden tube shorter, though, because eventually this head is going to be higher than the spool. Oh, really? I didn't know that. But materials have a hardness rating, a Mohs hardness rating, and ruby and diamond are much, much harder than these materials, so they're not going to be damaged by them. From what I understand, the filled filaments, like carbon filament, like carbon fiber and fiberglass and wood filament, the wear and tear comes from the nozzle rubbing on the previous layer, from what I understand. Are you on top chat? No, I'm on live chat. No, I don't do porn. Porn's boring, lame. So the idea behind the diamond and the ruby nozzles is that those materials are so hard that no filament you stick through them is going to wear them. So in theory, they should last forever. The issue is going to come down to the same potential issue that exists with the ruby nozzle, and why I would never suggest either nozzle to a beginner is the damage you're going to have is if you crash that nozzle into the bed. If you smash that nozzle into the bed. Yeah, that's a little too much, welfare god. Gotta be family safe, man. Yeah, I know they make a lot of money. There's definitely a lot of money in porn. How do you think they can afford to make so many movies? So, the issue is the nozzle is
two pieces. It's a two-piece nozzle. You have the ruby or diamond portion, and then you have the brass portion. Well, they do that because you want the heat conduction of the brass. I know that's what they do, but it's not family friendly. You know, the message has to be family friendly. PG-13. So the issue here, if you go to that link I posted for the nozzles, here I'll post it again. I don't want to switch on my screen because that messes up the audio sync when I do that. So if you go to that link and you click on the fourth picture, you're going to see a close-up of the tip of the nozzle. And you'll see that there's two pieces. You have the diamond polycrystalline portion, and you have the brass portion. He's trying to discuss porn, we're not. So if you smash that nozzle into the bed hard enough, first of all, diamond is extremely hard, but it is brittle. You can crack it. The other issue is that if you break the joint between the diamond portion and the brass portion, you could separate them. I don't know how theirs are joined in here. Do they show an interior? They do not show a cutaway. And I'm certainly not going to cut apart a $95 nozzle. My company was called So Screwed, and it was I think it was Egg Harbor News and Gifts, I think we called it. It's 25 White Horse Pike in 08215. So go to the 08215 area code on Google Maps and put in 25 White Horse Pike. That's the building. This one appears to like 295 Celsius. Once I increase the bed to 105 and the nozzle to 295, this is the high temperature hot end, so it can go past 260. All metal, no PTFE inside. It seems to like it. It's printing very well. There's no cutaway. I wonder if they have a cutaway on their site. Diamondback Nozzles does not work. Okay, so it looks like they don't have their site set up yet. There is a Kickstarter. Oh, there it is, Diamondback Nozzles. Okay, so Diamondback Nozzles forwards you to this site. Let's see, do they have any cutaways? Now you can see here, if you go to that link that I sent you to, and then scroll down, and you're going to see 4 sets of graphs. Alright, so at the first one that you see, it says thermal conductivity. Look at PCD and look at tungsten, and look at ruby, and look at brass, and then look at copper. For thermal conductivity, higher is better. No, we're just talking about them. I'm not going to suggest them until I use them. So you can see the thermal conductivity of the diamond material is dramatically higher. And that allows them to also make this the diamond portion of the nozzle thicker, which should make it stronger. Then you look at hardness, and you can see it's actually twice as hard as ruby, and substantially harder than tungsten carbide. Tungsten carbide is a little bit harder than hardened steel. And then you look at thermal expansion. Thermal expansion is not that big a deal for 3D printing, although you can see the thermal expansion of the diamond material is much, much better. This is made by Pryline. Let me get you a link for that.
I've used their filament before, and I like it. So far, it's been pretty decent for me. So thermal expansion is how much the material expands and contracts when you heat it. All matter expands and contracts at the change of temperature. So any material you use, when you make it hotter, it's going to get bigger. When you make it colder, it's going to compress and get denser. Most materials don't move that much. Tungsten carbide is worse than brass for expansion, and it's slightly better than hardened steel for hardness. The problem with tungsten carbide is it's more of an insulator. It's worse for thermal conductivity than brass is. And if you've ever used a steel nozzle, you know how bad they are. And tungsten is only slightly better than yes, the high temp head that comes with a hardened nozzle. Ronald asked if the high temp head for this printer comes with a hardened nozzle, and yes, it does. At least it looks like a tool steel nozzle. It looks like a hardened nozzle. So thermal conductivity, higher is better. You want higher thermal conductivity. Hardness, you want higher. Thermal expansion, you want lower. And coefficient of friction, you want lower. This is one of the reasons why they use plated brass nozzles, because plated brass nozzles have plated copper nozzles, because copper has excellent thermal conductivity. Matter of fact, the diamond nozzle is the only thing better than copper, but it has very poor hardness. It's got like no hardness whatsoever. It's got pretty poor thermal expansion, although better than brass, and it's got horrible coefficient of friction. Let's see. If you go to that link I sent you up here, up top there, the one that says Champion X, you can see the same charts that I'm looking at now. I'm not switching to them because we lose audio sync every time I switch. I'm not sure why. I guess we can switch and I can always reboot it again. So you can see here the charts. So thermal conductivity, higher is better. So you can see it's got better thermal conductivity than everything else, including ruby, which is horrible. If you've ever used a steel nozzle, you know what I'm talking about. They suck. So thermal conductivity is the ability of the material to transfer heat, to absorb heat. Higher is better because you're transferring more of the heat from your cartridge. It's also better for recovery. So you shove through a whole bunch of filament, it cools the nozzle down. How fast can the nozzle recover and regain its heat? This is thermal conductivity. Hardness, this comes into play only when dealing with weird materials. So if you're just printing nylon, polycarbonate, PETG, PLA, ASA, ABS, hardness doesn't matter. What you want is thermal conductivity. And also, this will come into play, especially for things like nylon and PETG. But when you start printing with filled materials, so fiberglass, Kevlar, carbon fiber, wood, glow in the dark, hardness becomes a very big issue. And as you can see, hardness is very good. Thermal expansion is how much the material changes when you heat it. This is not as big a deal. So on this chart you can see that diamond is the best by far. But the reality is none of our printers are printing accurately enough for this to actually matter. You're not going to have that much. Yeah, ruby is good for thermal conductivity, bad for coefficient of, or good for coefficient of friction. Ruby is good for hardness, and the only thing bad about ruby is thermal conductivity, which is actually a big deal because ruby is worse than steel. And if you've ever printed with a steel nozzle, you know what I'm talking about. They suck. That's one of the reasons that you have a problem with ruby nozzles. They have to make the ruby portion of the nozzle very thin to compensate for thermal conductivity issues. But the problem is the thinner you make that ruby portion, the higher the chance of you breaking it if you smash that nozzle into your bed or if the nozzle separates. Now, the good news is
the thermal expansion between... Now, I'm wondering how they deal with this. The thermal expansion of ruby is low, but the thermal expansion of yellow brass is high. That's going to cause those two parts to want to come apart when it heats up. Maybe it just doesn't heat up enough for it to matter, because I've never had a problem with the ruby nozzle. Now, this one here is actually more interesting to me. Coefficient of friction. One of the problems that you have with materials like PETG and ASA to some extent, definitely nylon, is the material would rather stick to your goddamn nozzle than stick to the fucking bed. So the material curls up and blobs up on the nozzle instead of sticking to the bed. This issue here should fix that. Coefficient of friction should help that quite a lot. Meaning the filament should not want to stick to the nozzle. It should not want to stick to the diamond portion of the nozzle. So as long as the stiction to the bed is greater than the stiction to the diamond, it should help with laying down those first layers and getting them to actually stay put. So this should help with boogering. If you've printed with PETG, you know what I mean by boogering, where little bits of the goddamn filament stick to the nozzle, and then later on it drops that burnt up booger into your print. If you've printed lithophanes, you know exactly what I'm talking about if you tried one with PETG. So in theory, coefficient of friction should help here. So this should help with materials like PETG, ASA, and nylon that would prefer to stick to the nozzle than stick to the bed. Obviously, I have to test this. This is a pretty dramatic difference. Although copper is the one that's really bad, which makes the whole chart look worse than it is. But as you can see, the difference with yellow, brass, steel, tungsten, and ruby is not that different. But this is a full order of magnitude times 2 reduction. So we're going from 0.2 with a ruby nozzle to 0.01 with the diamond nozzle. That should, in theory, make a big difference with those sticky materials. Will it? I don't know. We're going to have to test that. I'm probably going to stick the 0.8 on my Ender 3 Max. I like my Ender 3 Max. It's got a decent build volume. It's got good print quality. So it's worth it to put one of these $100 nozzles on it, I think. So I'm probably going to stick the 0.8 on the Ender 3 Max. And I'm probably going to stick a 0.4 on one of my CR6s. Or I can't do the Viper because that's a Volcano. Maybe I'll stick one on my Ender 2. I'll stick a 0.4 or 0.6 on an Ender 2. And because those printers have high enough print quality where we'll be able to see if the nozzle affects print quality negatively. I don't want to put them on a junky printer because then you won't be able to tell where the difference is. So I think the big test of this coefficient of friction, it says it's polycrystalline diamond, whatever that means. But on paper, obviously what's on paper and what works in real life are two different things. On paper, this nozzle looks amazing. This looks like an optimal material for 3D printing. What I would like is for them to make an entire nozzle out of PCD, like no brass. Just make the whole freaking nozzle out of PCD, like engineer the whole thing out of it. I think that'd be pretty cool. It'd also probably be pretty expensive. There's probably a reason why only the tip is the PCD. And I have a feeling that's cost. But it'd be pretty cool to have a solid diamond nozzle. Nobody makes nickel nozzles. I don't know why. Why doesn't anybody make a nickel nozzle? They make nickel plated nozzles. But nobody makes a nickel nozzle. So the problem with a nickel-plated nozzle is that these charts aren't going to make any sense. So the thermal conductivity of a nickel-plated nozzle is the thermal conductivity of brass. because it's 99% brass. The hardness would be attributable to the nickel and not the brass. Thermal expansion, you're going to have two values. You got the thermal expansion of the nickel and you got the thermal expansion of the brass. Coefficient of friction, that would be the nickel. So this chart would be difficult to place nickel on this chart because we don't have any nickel nozzles. All of these materials we have. And I think they show copper simply because it's a copper material. Oh! And isn't brass a mix of tin, copper, and lead? I think. The primary reason we use brass is because it's got decent thermal conductivity while also having being very, very cheap. The brass is extremely cheap compared to the rest of these materials and easier to work with because it's a softer metal. Nickel is also a restricted material under REACH. What's that mean? Damn it to hell, that print looks good. I love the look of carbon fiber infused filaments. They're usually worse because they're weaker, although polycarbonate should be strong enough to be able to take advantage of the stiffness increase from the carbon fiber. But visually, it's an extremely appealing material to print with. Oh, I didn't know that. I didn't know it was scarce. And I didn't know it was toxic either. Huh. Okay. Oh, here's the nozzle. I can show you that close up. See how it's two materials? There we go. So the concern that I have is the same as the concern that I have with the ruby nozzles, is that you have a piece that's ruby and you have a piece that's brass, which means you have two pieces. And if they aren't assembled correctly, then it's possible you could separate those two pieces by crashing that nozzle. So whenever you use a nozzle like this, or a Olsen ruby nozzle, you want to try to make sure you do not smash that nozzle into the bed. That could potentially be bad for it. Whether that's a problem with this one, I have no idea. So do they have any other information? Yes, very expensive. But it is USA made, which is part of where that price comes from. Anything made in the USA is going to cost more, especially if there's any labor involved at all. And the tip is solid diamond, not a diamond coating. It seems like the dream material for a 3D printing nozzle. I mean, there's no, besides the two-piece construction, you know, from a metallurgy point of view, there's no downside to this nozzle. It has the best thermal conductivity. It has the best hardness, and by a lot. I mean, look at the thermal conductivity from brass to here. You're 116 watts versus 543 watts. I mean, that's a 5-to-1 improvement on thermal conductivity. That's going to be huge. And the hardness. I mean, compared to brass, it's what is that? What, 25 to 1? No, it's gonna be like 35 to 1 improvement. Even ruby, it's double the hardness. I mean, it puts hardened steel to shame. It's 5 to 1 harder. It's 500% harder than hardened steel. And let me guess, you smashed it into the glass bed and broke the nozzle. Yeah, that can happen. You have to be very careful with these, and you'd probably have a similar problem here, depending on how they construct it. But Olsen rubies are wonderful. You just got to be gentle with them, you know, as far. Yep, exactly. And the ruby nozzle is harder than glass, so it will absolutely shatter the glass. And then the thermal expansion, the diamond is significantly superior to every other material we use. It's even still 2 to 1 better than ruby. But I don't think that's that important. I mean, it's good, because you're going to maintain your tolerances better. But I don't think that's that important. But these three are important. And in all three of these, assuming these values are accurate, you know, you got to take it with a grain of salt. These values are coming from the manufacturer, so obviously they're biased, intentionally or not. But assuming these values are accurate, this should be the dream material for these printers. So it's going to be interesting to play with them. Of course, that's easy for me to say. I got them for free. So that's really easy for me to say. But I'll be sure to put them through their paces and let you guys know what I think. But yes, this is definitely something, especially if you're printing on glass. The other bed materials, the materials themselves are soft, so you have a little bit of wiggle room there. But especially if you're printing on silicon dioxide or like ultra base, or if you're printing on glass, you want to be careful, because it will absolutely shatter your glass bed. Ooh, I'm sorry. And you could crack the nozzle. People say, how do you crack something that's as hard as diamond? Well, when you talk about how strong a material is, there are different ways to look at strength. All right? So, for example, rubber is very tough. Like, you can beat the piss out of rubber. I mean, we use it in car tires. Yet, I could cut your tire with this little knife, and I can take a screwdriver and punch a hole through it. Okay? So you see the difference there? Oh, really? I didn't know that. No known material. Diamond is extremely hard, but that hardness comes with a compromise. It's brittle. Now, it might not seem brittle to you and me, you know, compared to like glass, which I can take this and go tink and shatter it. But diamond is brittle. I mean, how do you think jewelers are able to cut diamonds into those little gems that we use in our jewelry? How do you do that? They're not cutting it. They're not taking a saw and cutting the diamond. What they're doing is they're finding the fault lines on the crystal, because it's a crystal structure. So they're finding the fault lines in the crystal structure, and they're chipping the diamond. So the diamond might be very, very hard. If I were to make a diamond fist and punch you in the face with it, I could punch straight through your skull, and there wouldn't be a scratch on the diamond. But if I hit some ceramic with that diamond just the right way, the diamond could break apart into pieces. Cleave them. There you go. That's the word they use in the industry. So you're trading. It's a trade-off. So diamond is very hard, while rubber is very tough. And there's a difference there. So when you pit the hardness of diamond against your filaments, well, that's nothing. Your filaments, no matter how much toughness they have, they can't touch the hardness. But glass has a pretty high hardness. And you smash a piece of ruby or diamond into a piece of glass, you're going to break the glass and you might cleave the diamond. So that's where you need to be careful. Not super careful. It's not like, oh my god, if I breathe on this wrong. No, it's not like that. Just make sure you don't smash your nozzle into the bed. That's all. Just don't smash the nozzle into the bed. If you're putting together a new printer, start off with your end stop higher, and then bring your end stop down slowly, so that you don't crash into the bed. Oh, interesting. So they use a diamond on a diamond. Isn't that cool? I wouldn't be surprised if there's an entire YouTube video out there that explains all that too. I would be blown away if there isn't a YouTube video that explains all that. So on paper, these nozzles look amazing. So I'm kind of excited about playing with them. Does that just take you to Amazon? Yeah, that takes you to Amazon. I'm surprised they don't have the 3-piece kit, because the 3-piece kit actually saves you a bit of money. Because these are $95 a piece, but if I remember right, the 3-piece kit is $260. Grab a piece of ice and hold each disc between your fingers on one end. Then touch the ice with the other. So take 2 flat pieces of ice and bang them into each other. Oh, you're talking about this. You're talking about using these to play with thermal conductivity. Oh, very cool. So, hey guys, this guy Scott Schmidt is from the company that makes these nozzles. So, if you have any questions, get them. Just out of curiosity, what would it take? I know it's probably stupidly expensive. What would it take to make the whole nozzle out of the polycrystalline diamond? Because then you'd have none of the problems with the brass. What would it take to do that? Would that be like insidiously expensive, or would it just be like a $200 nozzle instead of a $100 nozzle? Oh, I doubt it cost that much. I mean, they sent me a piece of the material here. I mean, that there is enough material to make a nozzle. You can't cut threads in diamonds? Really? I didn't know that. Because, I mean, that right there is enough material to make a nozzle, and they sent it to me in this kit, so it's obviously not that expensive. Yeah, I could see that. The issue with the cracking when you try to bore something that long? That makes sense. You know what? So these are machined, they're not grown. Huh. That would be amazing to have a solid diamond nozzle. The thermal performance would be incredible.
you're cutting it with laser. Now that's cool. It'd be really, maybe there might be some proprietary technology there that you don't want to show everybody, but it'd be really cool if you put like a video of that process on the website. You know, even if it was just showing, you know, cutting one of these or something like that. How did you guys, how, do you guys have a cutaway to show how the diamond is interfaced with the brass? Also, have you tested the brittleness compared to, you know, for example, if this were to crash into a piece of glass, which could happen on a 3D printer, does it hold up better than the diamond? I'm not sure how the metallurgy works with there. Well, that's not metallurgy. That's whatever this. I don't know what the science is for this. Well, don't show the laser. Just show, like, you know, one of these being cut. You know, like show one of the discs. You know, just that'd just be pretty cool to see. But yeah, I imagine there's some proprietary technology there. That's incredible. Using lasers to cut, you know, out of diamond to build stuff with. I just find that fascinating. Swaged. I am looking swaged. Oh, so kind of like making brake lines for a car. Okay, so you flare it, insert the diamond, and then bend it back to encase the diamond. So kind of like using a flare tool. Oh, now that would be interesting to try. See what we could do with glass with this. Oh. Okay, yeah, I see. So it's kind of, it's similar in concept to flaring a brake line for a car. Well, that should make for a good connection. I can't see that being a problem. Here, I'm going to make you a mod temporarily so that you can post links. So if you posted a link, go ahead and post it again. And it should let you do it. If you tried to post a link to a video, it would get rejected by YouTube. So go ahead and try to do it again. There it is. Now everybody can see that link. And that, oh, it's because I'm in Studio. That's because I have Studio loaded. I'm assuming I'm not going to get a copyright strike post playing this. What's polyphobic? Oh, is that Nozzle X? Is polyphobic Nozzle X? You know, a coated nozzle? Holy crap, it actually ground the ruby nozzle.
Yeah, that's still pretty impressive, though. Yeah, obviously that has nothing to do with yeah, that's the problem with the Ruby nozzles is they
A few weeks ago,
I suspect.
a monowheel is a vehicle.
Would you go away? I suspect that oh, we're getting pretty high up there. There we go. I suspect the obviously that's not commensurate with the kind of wear that a printer sees. That's like accelerated wear times 1,000,000. But still, the fact that the fact that the diamond nozzle said, "Bitch, you're the one who's going to be ground," and the grinding wheel disappeared. That's while it's not a valid example of the kind of wear a 3D printer is going to experience, it is very what's the word, poignant. It drives the point home. This material is very, very hard. Yeah, I figured once you hit the brass, the ruby just popped out of its socket. Aha! I got him! Any plans for a 0.2 millimeter nozzle? Because the let's see, where's the picture at? Where's that? There we go. The combination of coefficient of friction, hardness, and conductivity should make this a pretty good replacement for a 0.2 or 0.25. That would work as well. The only problem I would have with a 0.2 is, man, it would suck to clog up a $100 nozzle. That would suck. Yeah, that video is crazy. Like I said, that video is not a valid example for how a 3D printer is going to wear a nozzle, but it shows the hardness difference. And if you've ever printed with glow-in-the-dark filament, you know a glow-in-the-dark filament can destroy a brass nozzle in a single print. One print. I've seen people trash a brass nozzle in one print with glow-in-the-dark filament. Whatever it is they use in there. Hang on. Volcano compatible nozzle as well. You're going to make volcano versions of this? Yeah, because now my Viper is a volcano, and I would love to stuff a volcano on there. Oh, here we go. Nice. Okay, so if you go to where people ask questions on the Amazon link, there's a small video, and they show a small video showing a screenshot of a volcano compatible nozzle. So my biggest issue is the interface between the brass and the diamond. Yeah, I couldn't find the triple pack. Oh, there it is. Found it. I don't know why that didn't show up at the top where it should have. So. There's the link to the triple pack. But yeah, a version of this for the CR30 would be amazing. Oh, I shifted my stuff around a little bit here.
There we go. Fixed it. I wonder. You know, the reason I'm so curious about a solid diamond nozzle is I'm wondering if you can get similar thermal performance. Well, I guess you can get similar performance to the CHT nozzle. Have you seen the CHT nozzles? Is that like total fiction? Is there any chance that because oh my god, could you imagine a diamond nozzle with this? So this is a CHT nozzle, and you can see it has a triple hole cutout inside that goes from 1 to 3. And then there's material in the middle there. And the thermal conductivity improvement, because there's two issues with thermal conductivity. You have the ability of the material to transfer heat to the plastic. And then you have the ability, of course, yeah, this is a specialized nozzle. This is not just for general printing. And then you have the ability of the material to transfer heat to the plastic. So no matter how good the thermal conductivity of the metal is, the plastic itself has to be able to absorb that material. So by doing this, they split the incoming filament into 3 separate strands, which triples the surface area that the metal can then transfer heat to the nozzle. So I'm wondering, is that even feasible? Is it even possible to do that with a diamond nozzle? Like, I wouldn't do that with the small ones, but like you know, the 0.8 and the 1 millimeter nozzle, is that even possible to do that? Can the material be machined that way? I wonder if there's any good drawings I can show. Yes, you would have to license it from the company that patented it. But they are willing to license it. Like, the license can't be that expensive because the this set of 5 nozzles was what, 140, 100 bucks? So this set of 5 was 100 bucks, so the license fee can't be that high. So yes, you would have to license it from the patent holder. But that would be slick as snot. I mean, if you had a solid diamond nozzle with that kind of thermal conductivity, and the material would be even better because the lower coefficient of friction would decrease the issues of splitting the filament into 3 strands and then combining it again. Your laminar flow would be able to be maintained much better, especially when using fussy filaments. But now doing that with a 0.4 would be, I'm afraid to use the 0.4 from Bondtech. But a 0.8 or a 1, my God, the thermal performance you would have with a nozzle like that. And it would print anything. Like you could throw PEEK through that. Or you could throw any material you want through that. Here we go. That's not a great diagram. I'm looking for a better diagram. There we go. That's a pretty good one. This is not what it actually looks like. But that's kind of what they're doing. That's not that doesn't show the good part though. Where's the good part?
Well, you're aware of it, so you know what I'm talking about. By having that material in the middle there, I mean, you combine that with your thermal conductivity, your hardness, and your coefficient of friction, and I mean that's the ultimate freaking nozzle. I mean, it'll flow like snot, you know, like slippery as all hell. It'll transfer ridiculous amounts of heat, and it will not wear away. So, like, one of the issues you might have with the Bondtech nozzle is what happens if you try to stick carbon fiber filament through it. First of all, I would not do that with the 0.4 or the 0.6. I think you're going to have a fiber that's going to lay over top of one of those channels and just clog the hell out of that nozzle. But I think a 0.8 or a 1.0 would be fine. My concern with the Bondtech nozzle is, will it eventually wear away that central stator, basically, that's in the middle there, that's giving you that performance. My concern would be wearing that away over time. But with your material, it would never wear away. I mean, there's nothing you could feed through that nozzle that would damage that material. And I don't know, that would be fascinating. That would be absolutely fascinating to see what could happen with that in the future. And so I think I'm going to I'm going to put the 0.6 on my Ender 2, and I'm going to put the 0.8 on my Ender 3 Max. I think those printers have high enough print quality that we'll be able to see the difference, and then just go for it. I wonder if, I don't know, it's going to be fun. It's going to be a lot of fun. Oh, I think I found one. There it is. There's the... That's what I was looking for. That shows the material that remains in the middle. So you have 3 channels, which just dramatically increases the surface area contact patch between the metal, or in this case diamond, and the nozzle. So you combine that with the increased thermal conductivity and the lower coefficient of friction, and you would have a dramatic improvement in performance. Oh man, that is looking beautiful. Heck, I might stick to 0.6 on this printer. Oh, I don't doubt it. Yeah, you were mentioning that earlier, using the piece of ice to show the temperature transfer difference. I'm actually going to set up a... I wonder if I can see that difference with a thermal camera. Ooh, now I'm curious. Oh, no, this I am fascinated by. This is going to be interesting. I wonder if just my finger is going to be enough on the thermal camera. Okay, I'm going to have to use a intermediary material because you're going to get... The thermal camera is going to reflect. Yeah, it's going to reflect off of all the materials. So we're not going to be able to actually see the thermal energy transfer through the material, because we're going to see the reflection. So, like, for example, you can actually see what you're seeing there is the thermal temperature of my ceiling, because they're that reflective under infrared. These are very reflective under infrared. How could I take picture or video of that? I'm gonna have to come up with an experiment for that to see if I can visualize that somehow on a camera. That would be fun. I'll think about that. I'm gonna figure out a way to do that. I think that would be a ton of fun. So what is this? This is the diamond material, the ruby. I'm guessing is the shiny one the tungsten? Yeah, definitely. It's heavier. There's a big mass difference. As soon as I picked it up, I knew which one was which, because the tungsten is tungsten is a weird material because oh yeah, I bet. Tungsten is a weird one, but the ice experiment's good for me, but the ice experiment's not good for my viewers because they can't feel it. Tungsten is a strange material because it's so dense it feels wrong. Like you pick up a piece of tungsten and you just immediately subconsciously realize there's something wrong with it. It's too heavy. Like it shouldn't be that heavy. I got these little tungsten cubes I use for, putting nose weight in rockets, because all I need is this little tiny piece and just glue it in the nose of the rocket. And instead of having to add a whole bunch of lead to the rocket. But tungsten is just one of those weird materials that you pick it up and you go, whoa, something's wrong there. It's too heavy. So you'd think tungsten's a great nozzle material. For bigger nozzles, it's okay. But try printing with a 0.4 millimeter nozzle in tungsten. It sucks. Its thermal conductivity is so poor that, I was running 240 degrees with a 0.4 millimeter nozzle, and I was still getting lackluster print results. So, while it's harder, it's just not good for nozzles. Oh, interesting. I didn't know that. Yeah, you pick up a cast iron pan, you get a similar sensation because you're used to the weight of aluminum pans. So you pick up a cast iron pan, it's like, whoa, that's heavy. Well, you pick up a little tiny, I have some here somewhere. I don't know where they're at. I have a little box of tungsten cubes. I'll have to find them later. But yeah, it's that weird material. I didn't know tungsten and gold were similar. Wow. Wow. And what about gold? Now, what's the stone plate for? Oh wow, it's so similar. It's almost exactly the same. Holy crap. Granite. So what's the chunk of granite for? Oh, okay. So you can scratch the granite.
Holy crap, yeah. That's a big difference. That's just a little bit of a difference there. And give me a chunk to put on my thing here so it stops trying to tip over on me. There we go. So you can see the difference between the brass nozzle, which doesn't really do anything, to it. Come here, no mouse. Is the audio back? Alright, is the audio back? That should have fixed the audio. Pain in the butt. So yeah, that's pretty cool. So the other materials barely scratched the surface, but a single swipe with this scratched right into it. Where are you guys located? Now I'm curious. Woodlands, Texas. Oh, you're in Utah? Where is that located? I'm curious now. Oh, you're right next to Utah Lake. That's a nice big sizable lake. There you are. Yeah, I looked at Salt Lake City because that's a nice weather place to live as well, but whoo, living there is expensive. Well, the cost of living is actually pretty low. The cost of buying a house there, ouch. But it's a desirable place to live. Very dry. They got lakes. They got beautiful environment. It's a beautiful place to live. Yeah, there might be an interesting way for me to use like a temperature probe on top of each of the materials, freeze the block, and see the speed of the temperature transfer through the little disc. Let's get you back over here. we go. Come on, behave. There we go. And we get to watch the kitty cat over there by the door. 3D printing and kitty cats. Good combo. No problem. Hey, you sent them to me for free. I'm going to kick their ass. I'm going to abuse the hell out of them. Yeah, I got a probe. I should be able to just... Actually, just by putting something that's thermally opaque on top of it, I can use a thermal camera. But yeah, I can just hook up one of these with a thermal probe. There you go. There's a temperature probe. Absolutely. I don't know when I'd ever be up that way, but I'll take you up on it if I am. So worst case scenario, I can use a thermal probe. Best case scenario, I find something with, you know, it might even be as simple as just putting a piece of ice on it. You know, warm up that granite block, and then you take a room temperature disc and a piece of ice and drop it on the block and see how long it takes to melt the ice. And the conductivity difference should be dramatic enough to visually see a difference in the speed the ice melts. How's the thermal mass of the polycrystalline diamond? So how well does it retain the heat that you put into it? I guess that's a matter of density. The ice is a good in-person experiment, but the problem is I can't let you touch the ice through a video camera. So the ice experiment doesn't work on video. It works in person. Absolutely, I can imagine you're going to feel that right away. But there's no way for me to let my viewers feel the disc while I'm on a video camera. So I've got to figure out a way of translating that to video. You know, maybe this is a silly idea, but, you know, considering its coefficient of friction and its low thermal expansion, have they ever tried to use this stuff to put a coating on a frying pan? Would that even work? Probably be insidiously expensive. But that might make a killer non-stick pan. But again, I have no idea what the coefficient of friction and what the ability to transfer heat is of those other materials. I have no idea what those are. But yeah, a 1mm CHT style nozzle or 0.8 CHT style nozzle. Look into what they want to charge for that license. That might be worth it, because that would allow anybody to turn a standard $20 hot end, you know, or $50 hot end, into one you could do anything you want with. We are using the MakerPi P3. We are using the high temperature hot end, and we are printing Priline carbon infused polycarbonate. And it is looking absolutely gorgeous. I had to raise the nozzle temperature to 295 and the bed to 105 to get it to stick. because it did not want to stick. The box says, did I chuck that box already? Yeah, I think I chucked it already. The box says 8110 on the bed. Yeah, 80 didn't work. And it said 250 to 260 on the nozzle. Yeah, that didn't work. You really want to be at or around 300, and you want to be over 100 on the bed. Once I hit those temperatures, it started printing beautifully. You can see you got that beautiful sheen that you get from carbon fiber infused filaments. And this is running with no fan. Well, no, the issue was, for example, when the cooling fan hits the heat block, it draws heat out of it. Well, that wouldn't be nozzle, though. That would be heat block. So that would have nothing to do with the nozzle. So, yeah, that wouldn't matter. The heat block is where you want to have a large thermal mass. The nozzle, you want quick transfer of heat because you want the nozzle to adjust to whatever you tell it to. Wow. Now that's impressive. Even a 10 degree Celsius change that's an impressive difference. Because that means you could keep the temperature higher and greatly increase your print speed. Meaning you can go faster. Or you can go with a bigger nozzle. That's one of the reasons why the CHT comes with the 1.4 and the 1.8 millimeter nozzle, because the CHT allows you to transfer enough heat to print at that larger nozzle size, and the larger nozzle size allows you to increase your volumetric flow. So one of the reasons, like when I print something big like this. When I print something massive like this is 2 perimeters. So this isn't, 5 or 6 perimeters. This is only 2 perimeters. I'm using a 1.2 millimeter nozzle. Because I could print at a 0.4 millimeter layer height, and I could print at a 1.2 millimeter width, not only can I reduce my number of walls from 3 to 2, which it makes it go faster, but I'm printing at 30 millimeters per second, but I'm printing a larger, thicker layer, which means my actual volumetric flow rate is dramatically higher. In fact, my limitation on that printer is the ability to transfer heat to the plastic. Any faster than 35 millimeters per second, and the plastic starts shearing because it's not fully melting. So this nozzle and that nozzle will greatly increase the ability of transferring that heat to the plastic. The heat block is capable of it. The nozzle itself is not capable of it. So this will help with that greatly. So that should allow you to print a lot faster. In fact, you'll bump into your kinematic efficiency limit before you'll bump into your temperature limit. That's cool. That's very, very cool. Eventually you're going to hit an inertial limit. You're going to hit a limit to where going faster just destroys the print quality, because the physical components of the printer can't maintain their precision. They move and wiggle around too much. Too much what I call kinematic wobbling, meaning the frame itself can't handle higher speed. That is cool. It'll be interesting to see how fast I can print a vase mode ABS nozzle, or vase mode ABS nose cone. It might let me double the speed that I can print a nose cone. That would be cool. I hope this is strong, because this looks beautiful.
I love the aesthetic look of carbon fiber filled plastics. They make the material weaker, but polycarbonate should be strong enough that I can afford to make the material weaker to improve the stiffness. And just look at it. It has that that soft fabric-like texture look to it that you just don't normally get when you print with plastic. Like, one of my favorite materials to print with is carbon PLA. It's absolutely useless for anything that needs any kind of integrity because it breaks so easily. But it looks stunning, especially if you print a face with it, like you print some kind of character or face with it, because the soft texture lets you see all that. Oh. So this is not something you could apply as a layer to something. This is something that has to be pressed. 1 million PSI. Jesus. That's incredible. I mean, think about how violent a truck tire blowing is. And that's only 120 PSI. And you're hitting 1 million PSI. That's just incredible. Absolutely incredible. Have you thought of, just for shits and giggles, it probably wouldn't be practical to try to sell something like that, but and it might not work well. It might actually be a pretty poor idea, but make a heat block out of the diamond material that would fit within your 2-inch cube. Because the nozzle, you want rapid transfer of heat, which the diamond is excellent for. But for the heat block, you want heat stability. You want that heat to not change too much from moment to moment, so that you get a stable temperature through the nozzle. I also noticed that when you did the grinder wheel test, touched everything. Yeah, it would be interesting to see if that would actually end up being worse. Although aluminum doesn't have the greatest thermal mass, and that's what they're typically made of, is aluminum. I think they're made of aluminum. By the point? Holy shit. That's a good visual. That's actually a really good visual. Holy crap. I assume that is momentary PSI. Do you sustain 1 million PSI, or is like an impact where you hit it momentarily? So is it more like a press? What Creality printer? So is it more like a press or more like a hammer? Wow. Okay, that's a lot. Is there temperature involved there, or just pressure? Like, do you also have to maintain a really high temperature? Actually, you had a little chart on your site. Here we go. Copy image link. So you need to be in that 1500 to 2000 degree range while sitting at 1,000,000 psi. Wow, so it's hot and hard. CR5 Pro H. Oh, the high temperature CR5, okay. Oh, wow, that looks pretty. And it's got a top. Nice. Yeah, you have a little graph here that shows pressure versus temperature in the diamond sintering conditions. So yeah, 1500 C and 1,000,000 psi. That's incredible. So I noticed with your another thing with your grinder test that the diamond insert didn't pop out. So is that because you're able to use a larger chunk of diamond, so you have a better seating in the brass? I imagine the ruby is pretty thin in order to permit transfer of heat. Too thick and it acts as an insulator, which also makes it weaker. You know, you saw it flick it out. Oh, that material is so pretty. Is the diamond larger? Are you able to use more diamond material, or does that not really matter? Cool. Did you find the ruby? I guess it depends on what room it was in. Yeah, because that makes sense. Because from an engineering point of view, I don't design these things, but I have a minor engineering background. So from an engineering point of view, I would make the ruby thinner to compensate for its poor thermal conductivity. But the side effect of making it thinner is that it's more delicate. Your thermal conductivity is so high. Like, for example, if you tried to make the entire nozzle out of the ruby material, it'd be a sucky nozzle. It would really suck. But the advantage of the ruby is the precision and the hardness, but they have to compensate for the lack of thermal conductivity. Yours seems like, I mean, it seems like the perfect material. I mean, I can't, besides brittleness, I can't see any downside to it. How is the brittleness of the diamond versus the ruby? Like, is there a measurable difference? Where is that chart? Like, how well will the PCD hold up to being pressed into the glass? I mean, I think just the fact that you're using more material is going to help a big deal with that as well. Step on it. I'm not going to crash one into glass. I don't want to break one. I want to use them for a while first. But will the PCD chip? Like, will the PCD cleave? Or will it just, is it strong enough to hold up to that? Because that might make a big difference as well. Most of us are not going to crash nozzles into bed. Oh, okay, cool. Maybe after I've put a couple hundred hours on one of them, maybe I'll try it, you know, set the nozzle height a little too low into a glass bed and just see what happens. There's no question it's going to crack the glass. The question is, will the nozzle be fine? And of course, one of the biggest problems people have, grinding the nozzle into the bed, shouldn't affect the diamond nozzle at all. It's one of the reasons you use the ruby. It's not going to wear. Yeah, it's polycrystalline instead of monocrystalline. So the ruby is a single crystal, huh? I didn't know that. As if I'm going to see a difference. So that makes it tougher? Oh, okay. So the cleavage planes only exist in a monocrystal. That's interesting. Actually, that kind of makes sense. By using polycrystalline, those crystals are going to be all different directions. So none of those cleavage planes are going to line up with each other, because that's what you would have to have for it to be brittles. The cleavage planes would have to all line up, and then it would crack along that plane. And so because you're polycrystalline, all of those planes are going to be all over the place. It's going to be a it's not going to be homogeneous. It's going to be, every crystal is going to be in a different direction. Okay. So you don't have that continuous plane where it can cleave. That makes sense. That makes a lot of sense, actually. Yeah, I bet you do. So the ruby, like ruby, the lab-grown rubies, they're a single crystal. They're grown. Actually, that explains a lot. That explains something that I was curious about. Let me know if I'm right. Is that why yours is opaque and theirs is transparent? Because the polycrystalline nature of the diamond would probably also explain why light doesn't pass through it. Yeah, no light at all. Huh. That makes a lot of sense now. So is it not possible to make a polycrystalline ruby, or? Yeah, exactly. It bounces around until it comes. Well, the reason things are transparent is because all the light passes through in the same direction. You know, technically, all materials are transparent to light, but you're never going to see it because it's going every which direction. It's being spread every which direction. Huh. So you actually start off with a powder, and then you pressure sinter it into the block you need. Wow, that feels heavy. What's the density of this stuff? Like, what's the density of your... It feels lighter than steel. Similar to brass, but still feels lighter. So it's a low density material. Or low mass. That is cool. You guys should consider possibly selling that kit. People might be interested in that. Someone who's willing to spend $300 on nozzles would probably be willing to spend on something weird like that. Like, put it on your website or something like that. It wouldn't be worth putting on Amazon. You'd probably never sell enough of them to cover the FBA fees. But maybe on your website as a special order kind of thing, I think people would get a kick out of that. People like us who like this kind of stuff tend to like weird things like this. Yeah, it's pretty cool. So it's a nice leatherette case. Oh, very low density. Okay. And then inside you have the dust, the material samples, and this is the nozzle kit you would actually get if you bought the 3-pack off Amazon. And even this is very nicely packaged. So a beautifully made solid metal glass front. And there's your nozzles. There we go. And you get a sticker. I like stickers. I'm a sucker for stickers. I love how the threads always line up the logo with the nozzles inside. It always threads the same way. Very nice. What is it? Oh yeah, they put the tip on the rattlehead, the rattlesnake head. Nice. For those who are curious, they lined up the logo on the rattlesnake head with the tip of the nozzle. I like stickers. Stickers are fun. So you get a little... The orifice size is on the diamond. What do you mean? Come on. What do you mean the orifice size is on the diamond? Oh, on the nozzles themselves. Yes, 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 yes. I know what you mean now. I thought you were talking about this. No, I know what you're talking about. Here, let me get you a picture of that.
I am Groot.
I can get a picture of that. I just gotta find it. Hang on. I need more light. There it is. Come on. There we go. Well, it's not that much more pricey than a ruby nozzle. There it is. You can see the 0.6. You barely see it. There it goes. 0.6 on the nozzle. A little hard to read with the naked eye. Yeah, we gotta fill the rest of those holes. But if you do a lot of printing with carbon fiber, fiberglass, wood, and glow-in-the-dark filaments, it makes sense. So if you're not chewing through nozzles, it's not going to make that big of a difference, but it could make a performance difference. So if you're wanting to print at 200 millimeters per second, if you're wanting to print at 0.8 millimeters at 100 millimeters a second, if you're wanting to print high precision, high speed, that's going to work. But if you're just printing 60 millimeters per second with PLA, it's not going to make much of a difference for you. Oh, trust me, marking the nozzle is better than not marking the nozzle. That's for sure. Actually, I can show it to you on the website. Duh. Come on, they got a picture of it. So if you go to the Amazon link, you can actually see they have a clear picture of the 4, the 6, and the 8 on the nozzle. Might want to stamp it into the brass too, so that those of us with less than amazing eyesight can see what number it is. Hey, we're almost done. Yeah, I think I'm going to stick the 0.6 Diamondback on this printer here. I want to put the 0.4 on an Ender 2 for high quality. And the 0.8 I'm going to put on the Ender 3 Max. But the 0.6 I think I'm going to put on this printer. It'll be a good compromise of size versus speed. It'll be interesting to see how the polycarbonate handles coming to a point. And we'll see how the underhangs printed as well, because I have no cooling fan on for the polycarbonate. I was guessing polycarbonate is like ABS that doesn't like cooling fan. That's a guess on my part, of course. Maybe I'll just put the 0.8. Since this printer runs slower anyway, I'll throw the 0.8 on this one and just take advantage of the ability to print those thick layers. because this same print, I should be able to print with like a 0.24 layer height if I use a 0.8 millimeter nozzle. The step distance should be the same. Double the width, double the height. We'll see if it gets melty on the point. It looks like it's holding its shape. Maybe not. I see a little bit of blobby. Maybe not. Not bad looking. Yeah, that's going to be hot. That's over the temperature of boiling water, so don't go grabbing that with your bare hands, you dumbass. Oh, wow. It's still flexible even with the carbon fiber. Did that break or did that separate? No, that separated. Now we know we have that big booger there from when we were figuring out the temperatures. But damn, that looks pretty good. The underhangs look very good. I see a little splitting there. Oh, interesting. I wonder why there's a failure there. Look how there's a failure on the backside. Oh, isn't that interesting? I wonder what that's from. That would be a cooling issue. So either I needed cooling or it received cooling that I need to turn off. Meaning this could be induced by cooling coming off of the, especially the fact that it's not on this side and it's the same angle. I wish I knew. Oh wait, I do know the orientation. Where's the nodule? There's the nodule, which means the failures are 90 degrees from the nodule. The nodule was on this side, so the failures are on the back left corner. And you know something? I bet you the air from these two cooling fans is going to come out the back left side. So that might have been the fact that there was cooling where there shouldn't be. So I might have to actually put a little baffle on the bottom to make sure we're not getting cooling on the that portion of the print. That also explains the squishiness in the one direction because it's open here. It's got holes in it. But that is such a beautiful material. I absolutely love that material. Beautiful. First layer is a little rough because we were figuring out the temperature. So that is to be expected. Very cool. I like that a lot. And this material is not that expensive either. It's 48 bucks a kilogram, which for polycarbonate it's not that bad. hour 25 minutes. So I wonder why did the slicer think this was going to take 5 hours? Alright, that should take care of that. That happens. I don't know why. For some reason, either Windows or OBS drops the audio. It shows me getting audio, but you guys don't get any audio, and I have to restart OBS. So just let me know when that happens, and I will restart OBS. I got to figure out why I'm getting the holes. But otherwise, beautiful print. Absolutely gorgeous. Very pleased with that output. And I also did not get an error when the hot end hit 303, so I might be able to go to like 305. You're not going to be able to set that on there, but you might be able to set it in the firmware maybe. Not firmware, in the slicer. Sometimes you can override settings in the slicer. Anybody have any questions? It was easy enough to switch out the hot ends. The offset is a little bit off, I think. I'll have to adjust the offset. The printer had no problem recognizing the new hot end. I got no errors when I sliced to the higher temperature, so the firmware accepted the higher temperature. I wonder if it will accept the higher temperature on the standard hot end. Like, does it realize that the high temperature hot end is there and allow the temperature to go higher, or is it just allowing temperatures up to 300? It'll be interesting to test that. I had no problems in the slicer. All I had to do is pick T1 for the temperature and hot end. So when you, in Simplify 3D at least, the tool head is called Tool 0, Tool 1, Tool 2, Tool 3, etc. All I had to do was change from Tool 0 to Tool 1, and it used the second head. It'll be interesting to see if the IDEX system will automatically park the head when I instruct it to change tool heads. So I'm going to test that next. Maybe over the weekend I'll test that to see if I tell it to print a portion with tool 0 and then I tell it to print a portion with tool 0, will it automatically park tool 1 and bring out tool 0, or do I have to do a tool head change script to do that? I know with the Artist D that was all automatic. All I had to do was tell the slicer, okay, now use tool 0, and the printer itself firmware would handle parking the head and bringing out the second head. So it'll be interesting to see if this will do the same thing. I really wish they would make either the high temperature head or the flexible head E1, because I want to be able to print flexible and high temperature at the same time. For example, I want to print TPU and nylon together. I don't even know if they're compatible, but I want to be able to do that, and I can't because both the flexible and the
high temperature hot end are E2. So I would like to see them switch one of them to E1 so that we can, you know, have more. The firmware shouldn't be a problem. It's just a matter of them building an E1 that is either the high temperature or the flexible. Either one would work. Hopefully they will include the flex steel plate with the shipping units. There's a new landing page that I added to the description. So they just built their landing page for this printer, so you can check that out as well. So far, it's working well. Is this ready for prime time right now? No. This is beta hardware. This is pre-release hardware. It's test hardware. So they're going to obviously, well, hopefully, make improvements before shipping. So that's what we're doing. We're going through it and we're playing with the different hot ends. The reverse soft Bowden that they have set up, I think that's going to work well. It worked fantastically for this. I had no problems with sometimes when you pull filament, you're rolling a spool on top of a plastic tube, and sometimes when it does a retraction, that filament roll will bounce on the spool, and because the polycarbonate is so springy, it pops off the spool and unspools itself. Silks can also do that sometimes. Once you draw down some filament, that's not a problem, but when the roll is full, that could be a problem. That little reverse Bowden setup totally fixes that. That is this thing right here. That is that little clippy thing right there, and that little bit of Bowden tube right there. That produces just enough drag that when you have a retraction, the spool stays still. It doesn't move. So it keeps tension on the filament, and that is perfect. That's exactly what it needs. What they need to do, I think, is make the spool holder taller. I think they need to make the spool holder, you know, 50 millimeters taller. Yeah, make the spool holder 50 millimeters taller. It needs to be taller. Running it on the back side does work. It's not optimal, but it does work. So that might be a viable solution to that problem. So keep the existing spool mount them backside, and then have another clip on the front for holding on to the cable that goes to the tool heads. 45 degrees and a channel to hold them is going to be ideal for that. What else? That's it. I got to get some nylon. I should already have a Garolite plate out in the condensator, so I'm going to try to find my Garolite plate, and that'll make it a lot easier to print on nylon, to print with nylon, because I think nylon is going to be an ideal material. I don't have the new Ender 2, so I can't give any direct feedback on what I think of it. I have someone who's going to try to contact Creality to find out why we have a disconnect with them now. I'm not sure why they don't like me anymore. I don't know. Hopefully it's something that can be repaired, because I'd like to get one to play with. I'm kind of saddened they didn't put the new touchscreen interface on it. I would have liked to have seen that. I like that. Their new touch UI is not that bad. It's not great. It needs improvement, but it's not that bad. The biggest thing for me is I do not like the fact that the spool holders like the CR6 SE. One of the reasons to like an Ender 2 is that the printer takes less space. And one of the reasons the printer takes less space is because the spool is mounted on top. Now, that does cause a problem with the filament cutting into the feeder unit, but that is easily fixed by them simply putting a piece of this in the feeder to act as a friction bridge. That fixes that problem completely. You need literally a 2-inch piece of PTFE. That's all you need. And then that fixes that problem completely. But I would put the spool holder back on top. because part of what makes the Ender 2 so awesome is that I could fit 30 of them on this desk. Their footprint is so small that you could fit a lot of them all together, and that's amazing. It's awesome. And because if you have limited space, multiple printers is ideal because you can dedicate printers to different functions. So you could put 4 Ender 2s in the same space as one CR6 SE. Yeah, but still a decent bed size, exactly. And I could put 4 Ender 2s in the space of one CR6 SE, and I can dedicate those 4 Ender 2s to just cranking out all the regular little parts that don't need a huge build volume. Mostly X and Y, because it still has plenty of Z. And with the side spool holder, the Ender 2 now takes up half the space of the CR6 SE. So actually, you can fit 4 Ender 2s in the footprint of the machine itself, not counting a spool holder. You can actually fit 5 Ender 2s in the total footprint of the CR6 SE. Now you can only fit 2. So I would go back to using this kind of spool holder. Let's see if I can get it right. This kind of spool holder, like you see on this little screen here. Right here. There we go. On this screen right here. And to fix the problem with the filament, so what happens is the filament enters the feeder, but the filament curves around to the top of the printer. So the filament acts like a saw, and it cuts into the entrance of the feeder. Well, to fix that, all they have to do is drill a proper size hole at the entrance of the feeder unit, and then stick a 2-inch piece of PTFE tube inside of there. Your problem is now solved. Alright, when you wear out that piece of PTFE, which is going to take years, you cut another 2-inch piece of PTFE tube and stick it in there. So I would like to see them do that. The CR6 SE, the side spool holder, makes sense. It works fine. But if space is a premium, that side spool holder sucks, because it takes up all that space, and that's really, really annoying. So I'd like to see them go back to a top-mounted spool holder. Let me bring up a picture of it. Oh, does it come with that garbage soft bed? Exactly. Okay, so here is a picture of the... Let's see if I can do this without losing the audio. Do you guys still have audio good? So, I also don't like this. I don't like this screen sticking out the side. I would rather go back to the integrated screen built into the printer and just mount it at an angle. Because this makes the goddamn printer bigger again. I mean, you're making the printer larger. Now, I understand why they did this, because the spool holder's here, so it's not really taking up more space. But the moment I put that spool holder back on top, now I've got this big janky screen sticking out the side, and I'd like to make that go away. Yeah, it's almost Ender 3 size. You're defeating the point of the Ender 2. The whole point of the Ender 2, it was just so incredibly small. Now, I'm not sure how much I like the fact that they went with the 4-point bed attachment. That adds mass, and I don't think there's a reason to add that mass. Although I will admit, getting to that third screw was a pain in the ass on the Ender 2. It wasn't bad, but it was a pain in the ass. This will be a little bit easier for users to interact with. Are those metal wheels? Are they plastic? I don't know. I'm okay with the tensioning, even though I'd prefer not to have it there. That's fine by me. 3-point is usually actually better. It's easier to level a 3-point bed.
if the bed's flat. If the bed is flat. So, what I'll get to you in just a second, Dark Shift. What would I have done to an Ender 2 Pro? Okay, the first thing I would have done was I would have put 2 rails on it. I would have gone 2 rail. Think miniature Ender 3. Okay, but I would have gone to 2020 rails instead of 2040. This is a 2040. By having 2, I could switch to 2020, making it smaller. I would then mount linear rails on the Z-axis instead of the wheels. Linear rails would allow me to make the machine smaller, even smaller than it already is. The next thing I would have done is the screen would have gone back onto the bed here. I would have definitely gone back on to building the screen into the face here, and I probably would have gone with an OLED screen about half this size, so a little bit bigger than the original, but OLED. That'll make it easier to read because it's more crisp. I would have gone with the Tivo Michelangelo style Y-axis motor by mounting this motor inside the chassis here and having that double bend around the pulley system like the Michelangelo uses. That would allow me to shrink it on the Y-axis, make it even smaller, so you don't have this motor sticking out the back. I would have gone with a linear rail on this axis here. I'd get rid of the tensioner and use a shrunken down stock tensioner style system. Spool would go on top, of course. And the bed, I would have gone with a 6mm bed, and I would have made sure it was a high power bed, 24 volt, so that I can crank up that temperature, 150, 160 degrees, because now take this here and add this to it. Where is it at? Slap this on it. It'll bolt right onto the printer. So you combine that with a high temperature bed and a steel mag plate, not that stupid flexible crap. Is it that soft one? Did they go back to that soft one again? The single speed feeder is okay. Just go with the aluminum one. Don't use the plastic one. I'm guessing they stuck with their plastic one that they always use. But yeah, that's what I would have done for an Ender 2 Pro. I would have gone to a bed that could hit higher temperatures. I would have gone to I would have stayed with the metal clad hot end because it's easier to take apart and mess with. I don't like the new plastic hot end setup because it's just annoying. So flex plate, not the flex peel. I would have gone with a 6mm aluminum PCB heat bed and make sure it was machined, not cast, so that it's not going to warp. And I would have gone with this hot end on it. I'd have stuck that hot end on it if it ends up being good. We don't know if that's a good hot end or not yet, because I can always just stick a mosquito on there. I would have then had a by doing that, by doing what I just described, by having all the electronics in the bottom, seal the top from the bottom, put a lip around the bottom, okay? By doing that, I can then make an enclosure, a very affordable enclosure that would slide right over top of the entire printer. And now you have an enclosed high temperature printer. Now you can throw some peak and Ultem through this thing, and it wouldn't be expensive. I might try to do this.
That's part of the reason why I would go with linear rails. That's part of the reason why I would go with a double vertical rail. Okay. The double vertical rail would increase the width, but I would basically increase the size of this base plate to the maximum travel size of the printer, so that I can then have a lip around that entire base plate, and I could slide a enclosure right over top of that printer and engage with that base plate. And then all the electronics would breathe air from the room, so your electronics would not be experiencing the high temperatures that the printer is experiencing. In fact, the only stepper motor that would even be in a high temperature environment would be the X-axis stepper motor. The other stepper motors would actually be inside the base, where they could be cooled properly. That's what I would have done. That's how I would have done an Ender 5 or Ender 2 Pro. I would have turned it into a miniature all-purpose monster. So I would have made that machine a beast. And I might try to do that. I have 7, 8, 9, I have 11 Ender 2s. So I may sacrifice one to try to do this. But yeah, this does not impress me. This to me, this is a Ender 3 with a smaller build volume. Because one of the things that made the Ender 2 so amazing oh yeah, I just made a mess. One of the things that made the Ender 2 amazing was how small it is. You know, how little desk space it consumes. Especially if you, for example, mount the power supply underneath. I just knocked over who knows what. I think I knocked over a drill. But yeah, there's a lot they could have done to really compress this printer to make it take a lot less space. And I don't know. By having all this crap sticking out the side of the printer, it's now no longer a compact printer. It's not that much smaller than an Ender 3. Oh. The price is, even the price is not that great. It's $170. That's only, you know, $20 cheaper than it was when the Ender 2 first came out. Now, I mean, granted, it does have a bigger screen. It does have a I'm assuming it's, I hope it's 24 volt. I'm assuming it's 24 volt. It does have parts cooling now, which the original did not. The original was the best printer money could buy. Period. I'll pit my Ender 2 against your Prusa any day of the week. I'll pit my Ender 2 against a $3,000 MakerBot any day of the week. And my Ender 2 will kick its ass. The print quality I get out of those machines is simply mind-numbing. It's uncanny, the kind of print quality I get out of that machine. And it comes down to it being light. So it's not moving a whole lot of mass around. Hello, Yamaha. I mean, people look at the prints that I print off of an Ender 2, and then I tell them it came off an Ender 2, and they're like, no way. And I'm like, yeah, way. And without having to slow down. You know, printing at normal 60 to 80 millimeters per second, no problem. And so basically, I'd probably be better off starting with a King Rune. I might try to build one. The problem is I have no money. I can't build one. I don't have the parts. I might be able to cobble together enough extrusions to build one. You know, I probably have a few printers that I don't care about that I can cut apart and use for parts. But I don't have enough. I mean, what I would really love, I mean, what I would find amazing, I don't even know if it's possible. Maybe it's not possible. But I would love an Ender 2 that is basically an Ender 5 shrunk down. By shrinking down an Ender 5, the trick would be making the kinematics smaller. I don't know. I would love an Ender 2 sized Ender 5. You know, give me that a 150 by 150 by 225. I would even accept a hit on altitude to keep it smaller. But I would love a downsized Ender 5. You know, smaller extrusions, keep it smaller. Use linear rails in order to reduce the footprint, so that because you don't want the motors sticking out the sides. Yeah, but the Voron 0.1's a $450 printer. I want a $200 printer. And the Voron also has a ton of wasted space. Hang on. Jesus Christ, let me hit the right key. Let's see, where's a good angle? So my problem with the Voron 0.1 is, first of all, it's expensive, and second of all, it's huge. I mean, relative to its print volume, the printer is massive. I want Ender 2 footprint. I want small. And not 100% sure how to do that yet. I got to think about it. I got to work on it, but I think I can do it. I think there's a way to do it. Do they make smaller linear rails? So right now, a linear rail is, you know, well, how big is that linear rail? That doesn't look that big. In fact, that looks like it's 10 millimeters. Where's my tape measure? So the Voron 0.1 is small relative to a Voron regular. But compared to an Ender 2, I could probably fit the damn Ender 2 inside of that thing. Ow. Yeah, it's only got a 120 cube build volume. I would want a 150 by 150 by 200. That's my conditions. I want 150 by 150 by 200. Because 150 millimeter allows me to print a 3-inch nose cone. No more than that. That allows me to print a 6-inch nose cone. But because 75 millimeters is 3 inches. Yeah, so it allows me to print a 6-inch nose cone or a 6-inch centering ring, meaning the Ender 2 with a 225 height. The nose cone will be a little short for a 6-inch, but the nose cone will be pretty good for a 4 and great for a 3. Ideally, you'd want 250 Z height, but that's pushing it. But you could just extend the height. Height is usually not a problem. It's X and Y that are the problem. I'm okay moving into Z. What I want to do is shrink the X and Y. I want to shrink the footprint of the printer. So this printer is... What are the dimensions of the printer? So the printer is 212 by 230. That's its footprint. The case, yeah. So that's pretty big. I'd like to get under 200 by 200. Basically, I'd like to get down to the footprint of a spool of filament. So I would like to be able to have a spool of filament just fit. And how big is a spool of filament? So a spool of filament is 200, yes. So I'm trying to get a case size of 200 by 200. So at least I was right on that. 200 by 200 is my goal. I want the total footprint of the machine, like including switches, plugs, everything. I want the total footprint of the machine to be 200 by 200. And the spool would sit on a bearing on top, kind of like the old FL Sun Delta printers did it. So they would sit on top and then unspool into the machine. Or underneath. You could do it underneath as well, but top down would be better most likely. You could also stand the spool up without a problem. Again, as long as it's in that 200 by 200 footprint, you're good. So standing it up is no bigger. It just makes the printer taller, and that's fine. But yeah, so it would probably, see the problem is that it would be best to use a mosquito hot end, because the mosquito hot end will allow you to push the stops. You're going to have an end stop and an end switch, because you got to home it, and you have to have enough track. So the how can I show you that? I can, here. The Voron point 1 is pointless for this description. It's too hard to show you. Ender 3. There's probably a zillion pictures of an Ender 3. There we go. This is the picture. And of course, it's a tiny picture, but it's okay. It's good enough. So here's your printer. So you're wasting a lot of space off to the right here, because your nozzle is here. So you have to have enough space to get all the way to here. So this much area from here to here has to move past the edge of the bed. And then you have to extend this even further because you've got wheels here. And you have a tensioner here. And all of that has to extend past the edge of this space here. So one idea I got was to no tensioner. Get rid of the tensioner altogether and simply have a ball bearing hole with the drive on the end of the on the end of the spool here. And then you would have a tensioner built into the hot end. And it would be like you'd go in there with a screwdriver to a knurled wheel that you would feed the belt through, and then you would simply tighten that, and that would tighten the belt. That would allow you to, and by using a linear rail, that would allow you to shrink all of the x-axis almost as small as the bed. So the idea is 150 millimeter bed. Even better would be 160 millimeter. That would be ideal. 160 millimeter bed, and then you'd have the 20 millimeter rails. That's 200 millimeters. Now keep everything inside that. So don't let nothing extend out past the edge of those rails. And you could cheat a little bit. Actually, there is a pretty good way to cheat here. You could turn the rails this way, and then have the wheels run up and down the sides of the rail this way. That could work. And then you'd fix the Z-axis problems, like you can get rid of all of this simply by having linear rails. And then you would mount the motion system for the motion system. You would mount it right here. So the stepper motor would sit inside the profile of the vertical rail. And that would allow, what you'd probably have to do is belt drive down and over, or just let it stick out. Literally just have it a plate here and let it stick out the front. Because it's okay if it sticks out front to back, because it's not going to move front to back. so it'll still be within the 200 by 200 build volume. Let's see. The feeder system would also have to be profile mounted, because you'd have to move it as far left as you can. That would be a tough one. Actually, where it is would work fine. Yeah, where it is would work fine. I might even move it closer to the center, lift it up a little higher and angle it a little bit to help with the angle getting up to the top of the printer, so that the filament path would be smoother as it routed itself around to get into the feeder unit. Although direct drive would obviously be the best. I mean, it'd be great to be able to do a direct drive. All the electronics would be in a sealed base so that their airflow is separate. That wouldn't be a problem. Change everything out to 30mm fans in order to shrink the hot end. But the big thing, the most expensive part, would be the bed. Because I would want a mic'd, a properly mic'd 6mm thick bed. I would want a bed so goddamn flat that, you would never have to worry about that bed warping, ever. And then, probably the cheapest way to do that would be to use an Ender 2 heated bed bolted to a mic'd aluminum plate and have it cut out for that aluminum bed to bolt right to it. I would use a split rail for the bottom. Since we're going to have a full metal base, I would use a split rail for the bottom and 2 linear rails for the bed. That would also help keep the bed structurally stable. There'd be no reason not to. Do they make 1020 rails? I don't know if they make 1020, but 2020 should be enough. Although the reality is, what you'd really want is 2040 standing up, because you want to be able to make sure you can get your fingers to those levers, to the wheels. I don't know. I gotta think about it. I'm trying to think of a way to do it, but also a way to make it something I can afford to build. It's the kind of thing where, I'd have to buy one part each month because I just don't have any more money for it than that. I could turn this off now. We're done with this for now. That'll make the video a lot less noisy for you. But yeah, it'd basically be a hybrid between Ender 3 and Ender 2 and an Ender 5. I would love to go with the cube structure, because the cube structure would allow me to build the whole thing out of 2020, because the cube would make itself stronger. I'd have to design it first, make sure it's feasible. Actually, you know something? That's something I could 3D print. It wouldn't be functional, but I could 3D print this. And that would allow me to test fit, make sure things work. Yeah, I could 3D print this. Rotating bed? What do you mean rotating bed? I think the best thing would be to take an Ender 5 and see, not an actual Ender 5, the design of an Ender 5, and see how compact can I make it. How compact, so the problem you're going to run into is you have the bed, and then you have the frame. So there's a space between the rest of the world and the bed. And the frame, the structure of the printer takes up that space. The trick is, how tight can I make a printer so that the frame of the printer is minimally larger than the print area of the printer? See, that's the problem with the Voron. You have this big, giant space being consumed by the printer, but you're only printing on this little space here. So the question is, how tight can I make these differences between the print bed and the outside of the machine? So that would be the goal, is to compress it down as tight as I can get it, so that the machine is only slightly larger than its print bed. So about 40 millimeters. I'd be looking to try to take a 160 by 160 print bed, and that only leaves me with 40 millimeters on all four sides to fit everything else. And that should be doable. That should be possible. 2020 rails would give me just if we're at 210, I'm fine. It doesn't have to be like, oh, you went to 201, you failed. No, if it's 210, I'm fine with that. But as close to 200 by 200 as I can get, while still having a 160 by 160 build volume, and while keeping the total print height under 300, not counting the spool. Because when I travel, one of the things I do is I carry those little 250 gram spools with me. I save them. I don't use them, especially when I get them in printers. I save them because they're great when you're traveling. So the trick is, like, linear rails will help you compress. Using double verticals will help you compress. Using a smaller hot end and smaller fans will help you compress. So, for example, I need the hot end, the distance from the tip of the nozzle to the extreme right or left of the carriage, I need to keep that less than 20 millimeters. So, I got one right here I can show you. So, I need the distance from this nozzle to the edge of the carriage to be less than 20 millimeters. Because otherwise I have to extend the x-axis that far outside of the volume in order to get it to work. Now the y-axis is actually really easy, although I would prefer to use an Ender 5 style y-axis. But we can start off with a regular Cartesian, we can start off with a bed slinger to keep it easier. But having a fixed bed would make this a lot easier. So Michelangelo style y-axis. That solves that problem. That also means I don't need tensioning at all. So all I need is a pivot, a ball bearing pivot on each end. And those can easily be less than 20 millimeters, which means they won't extend more than 20 millimeters past the end of the movable bed volume, because there's no stepper motor there. It's just a pivot. So that's easy to do. So the diameter of the bearing will determine how much extension I need. And if I have room, I'll use a bigger bearing just because it'll be more stable and last longer. Like if I can use standard skateboard bearings, that'd be perfect. Get some SDI bearings, and they'll last forever. They'll be sealed. That'll also allow me to support it better. It'll be much stronger. And then to tension it, you could tension it by, well, there's two ways to tension that would be effective. One is to tension the stepper motor. So you would tighten up a screw that would move the stepper motor a little bit. The problem is that's you would need some sort of a rail no matter which way you did it.
So I would mount the stepper motor to an extrusion and allow the stepper motor to move along that extrusion using a screw, so you can tension the stepper motor, which would tension the belt. That would shrink the y-axis and easily get me down to 200 millimeters, because you'd have the 160 millimeter bed plus the you see, there's the problem. By using a bed slinger, the minimum travel for the bed has to be 130 millimeters. Because if the nozzle's not moving, the bed has to move 130 millimeters from center in both directions in order for the nozzle to reach the full length of the bed. Which means the minimum size for the depth of the printer would be 260 for motion, 130 forward, 130 backwards. That's 260 motion. No, wait a minute. The volume is 160, so the motion is 80. Motion is 80. So yeah, that should be doable. That should be possible to move, keep the bed within a 200 by 200. Okay, I was thinking wrong. Why would you rotate the bed like a turntable? What would be the purpose of that? You talk about like one of those polar 3D printers? I would prefer not to move the bed. That's why I would like to do an Ender 5 style printer, because then I don't have to move the bed. I meant joining beds in a triangle. I don't understand. I'm not picturing that. What? I'm not visualizing that. That's a difficult thing to do when you have something in your head and you want to transfer it to someone else's head. That can be very difficult to do, so don't feel bad. That's one of the reasons why I consider, effective teachers to be like, artists. So I guess the first thing would be to take an existing printer. I could probably find all the parts of an Ender 3 3D printable. I'm willing to bet you somebody has a fully 3D printable Ender 3. And so I guess start with that and see how much I can shrink it. How much can I shrink the carriage plate for the hot end? How much can I shrink the ends? Basically, how small can I make all these parts? Like, for example, I can shrink the end stops. So you have an end stop. Is it on here? No, it's not. So you have an end stop with a little lever on it. Click, click, click. The carriage goes click and clicks the end stop. Well, instead, I can mount the end stop up here with a roller wheel. And now the top of the hot end will click and hit the roller wheel of the end stop. That would eliminate the X dimension space consumed by the end stops. So that shrinks the width of the printer. Yeah, that would take a gargantuan amount of space. I think I know what you're talking about. You're talking about printing on a pyramid. And then you'd rotate the pyramid and print on a new surface, and rotate the pyramid again, print on a new surface, and the old parts would fall off. Yeah, that could work, but it would be huge. It'd be very, very large.
Your best bet to do that would be to simply have a longer bed. So you'd put two beds together, and you'd move this bed out of the way, and now you're printing on this bed. Okay, so kind of like an IDEX print, but on the y-axis. And then let this bed cool down while this bed's heating up, and you'd start that print. And once that bed's cooled down, you can actually use the X-arm as a wipe to push the first print off the bed. The problem is, if it didn't release, it's going to hurt. Probably your best bet would be to use a polygon cylinder. So, like or even a square. A square would work well. So you'd have a box, and that box could rotate like this. So you'd have the box sitting on top of the bed doing its movements while you're printing, and then when you're done, you'd rotate the box like that and start printing on this surface. That's something you could actually add to an existing printer. If you started off with an Ender 3, add 100 millimeters to the Z height to make room for the rotating box, and then print. Then have the box programmed to rotate 180 or 90 degrees. Print. And then when the box rotated again, the part would hit a scraper bar down here and would pop the part off. And then you'd print again, pop the part off, print again. You could do that. A box would work better. In fact, the closer you got to a circle, the better it would work. But I think a box would probably be the best compromise. Your best would be an octagon, because that would allow you to get that scraper. Right now your scraper bar can't get any closer than this to the part, but an octagon would get you closer to the base of the part. Just get a Quinley. What's a Quinley? I'm assuming that word is not going to help me in a Google search. Oh, there is. Oh, yeah, there you go. Scraper bar. That's kind of neat. Now, one advantage of using a rotating bed, well, the disadvantage is leveling that bitch. That's going to be tough. Getting that bed to rotate in exactly the right position every single time. If you used a raft, no problem. Now, one advantage of printing with a printer like this, with an octagon-shaped profile that rotates, is don't try to remove the part at all. Instead of trying to remove the part, just use sequential printing. Make the bed wider, but narrower. And so you'd print, 3 or 4 parts, rotate 3 or 4 parts, rotate 3 or 4 parts, rotate 3 or 4 parts, and you could do that 8 times before you'd get around to the first bed again, and then just stop. If you're printing, say, for example, this, I could print, 5 of those in that width, and that would allow me to print 40 fins before I'd have to come attend the machine again and just clear off all the parts. That'd probably be more reliable, but otherwise you would need to be using some sort of a scraper bar. So like the Quinley he showed you, like the guy from Maker Faire who was doing the automated print factory thing where he had the little snowplow scraper that would come out and push the part off. That's pretty cool. But yeah, it'd be interesting to see how small could I make a printer, how efficiently could I make the printer relative to print volume versus machine volume. At least on the X and Y. We're okay extending into Z, but get the X and Y as close to 0 as possible for the print volume. If I can get it down to like roughly 20 millimeters, 24 millimeters, that'd be great. Because that would mean you would have a 3D printer that would fit. My objective is a 3D printer that does not take up any more X and Y space than a spool of filament. 200 by 200 millimeters. Not round, square, but the same XY volume as a spool of filament, while still giving me a 160 by 160 by 225 print volume. Ideally 250 would be nice, but I'd be okay with 200 or 225. But having, and you could even make shorter ones. For example, if you're just going to print small nose cones and centering rings and stuff like that, then you only need 100 millimeter print volume. That's all you really need. And then you can start stacking the machines. But yeah, that's my objective, is a 160 by 160 by 200 print volume inside of this build volume. That's what I want. Hey, if Creality wants to make it, I'd make a deal with them. Pay me a royalty on each machine. I'd be happy with that. I'd be very happy with that. There'd be nothing stopping them from just copying it, but, you know, because I would open source it. But it'd be nice if we can make out that kind of deal. But I'd like to do that. I'd like to try to see how feasible it is to do that. To try to have that kind of a miniaturized build volume. What's the smallest hot end currently available besides the Mosquito? Is there a although to be fair, the stock Creality hot end is actually pretty damn tiny. It's not that big. So I would just start with a Creality hot end. You know, it's all the stuff around it that makes it bigger. And I could shrink that, you know, 30 millimeter cooling fan. Well, hey, you know, anything's better than zero. I'm going to open source the printer, so there's nothing stopping them from just doing whatever the hell they want anyway. But if they decide attaching my name to it is worth something, you know, hell, if they gave me $5 per machine, I'd be a very happy person. Pico Hybrid Hot End. Oh wow, it's very tall, but that is small. Okay. And Revo Mini. Where's the hot end? Oh wow, that is compact, but not that much more compact. And see, now what I don't, now see, another thing that's important to me is simplicity, cost, and serviceability. This hot end is not that much larger than this hot end, but this hot end is serviceable. I can replace that thermistor. I can replace that heater cartridge. This one, I'm guessing that this is not serviceable. That this whole thing would have to be replaced if anything happened to it. I don't know. But my guess is it's not serviceable. But that is pretty damn small. Now what I don't like is that you now have a special cartridge. And that kind of bugs me a little bit. I don't like proprietary. I'd rather stick with something that uses, you know, standard nozzles, because that will allow you to put a Bondtech CHT or a Diamondback nozzle on your printer. While if you go with a special nozzle, you're limited to whatever's available from that one special nozzle company. Yeah, I have a little cat. You see my little cat? If you guys are, any of you guys from the Windows 95 days will remember this. Little Nico cat. Where'd he go? He's probably going to appear on the big screen. Yep, he's on the big screen now. That's my little Nico cat. He just lives on my desktop. So I wouldn't go with something like this because of that. So I would want to stick with standard blocks. Now, I could shrink the block by going with copper, because copper has a higher thermal mass. So go with a pure copper block and shrink the block to the width of the heater cartridge. So there are ways to shrink that down, but I don't think that'll make a big enough difference on the printer. I think the limiting factor on this printer is going to be the kinematics, not the hot end. I know plenty of ways to make that hot end smaller. I'm not worried about the size of the hot end. The tricky part is going to be engineering the kinematics to stay within 40 millimeters. And that's split in half. So each side has to stay within 20 millimeters. So, you know, things like, you know, this section, everything you see there would have to be shrunk down to fit within this width, 20 millimeters. So that means no wheels. So we switch to linear rails. That allows us to stay within the profile. No tensioner. So we get rid of the tensioner and we simply have a ball bearing pivot, and then you put the tensioner behind the hot end. You put the tensioner inside the carriage. Yeah, I wouldn't want to use that. I want to stick with your standard Okay, the audio should be back now. So because I don't want to go for I don't want to go for extreme bleeding edge performance in that regard. I want to use off-the-shelf parts as much as possible. Obviously, the frame would have to be custom parts, but beyond that, I want to go with as close to off-the-shelf parts as I can. In fact, I just realized a problem. How do I solve that? One of the problems you're going to run into, for example, if I go with an Ender 5 style architecture, here we go. So, one of the problems you're going to run into is that when you shrink your machine volume down, you're going to have an overlap between your X and your Y axis. So they're going to overlap. And that could be an issue. So how do you keep them from overlapping? So for example, if I mount the hot end in between these two rails, well, now my build volume becomes the width of the machine minus the width of the two profiles minus the distance between the edge of the carriage and the nozzle. So let's say I get 15 millimeters from the nozzle tip to the edge of the carriage. That means if I had a 200 millimeter machine, I lose 40 millimeters to the two rails and I lose 15 millimeters to the width of the carriage, which means my build volume, and that's on each side. Yeah, that's on each side, so that's 30 millimeters. So now I'm limited to 130 millimeter build volume. So I have to figure out how to overcome that. Well, one way you can overcome that is by moving into Z. So if I were to hang the X carriage below this rail, well, now I can put a linear rail on the bottom of the I could put a linear rail on the bottom of the X-axis rail and restore full travel distance for the linear rail. That's one way to get past that point. Then how do you move on the Y-axis without a conflict? Well, I can make the Y-axis two rails attached in the middle here. So I can have a rail here and a rail here. So that the X carriage could move the full width of those two rails because they would be between the outer frame rails. So I would have 4 rails this way and 4 rails this way. So you'd have your 2 frame rails, and then you'd have your 2 Y-axis rails, which would give you full travel distance along Y, and then you would have you'd still lose distance on the Y then, because if I made the X-axis the full width of 200 millimeters, it would then crash into these arms here. So it would have to stop when it reached those arms. Yeah, here's the cat chasing the mouse across the screen. Right here. I love my little Nico cat. Boy, this is getting complicated. So 200 by 200 might not be possible if I want to stay with a 160 by 160 build volume, because the X and the Y have to have an overlap. Now, if I don't go with an Ender 5 style and I use a bed slinger, I can make that smaller. That would work. So we might have to go with a bed slinger. We might not be able to go with a what is this, an H-bot? What do you call the Ender 5? It's not a Core XY. It's Cartesian still. You just swap the Z and the Y. But what do you call the Ender 5? Because I'll go with a bed slinger if I have to, but I'd prefer not to have a bed slinger. I would prefer a cube. Because a cube, I can just grab that cube, stick it in the car. You can't chuck it, but you could. It's a lot more reliable to go with a cube. It's a lot more reliable. Z-axis is no problem. I could put the kinematics in the profile with, so I'm not worried about the Z-axis. What I'm worried about is how do I overlap X and Y? I think I might have to compromise and make the Y-axis longer than 200 millimeters. There might not be any way around that. think. I might have to add 40 millimeters to the printer. I might have to do 200 by 240. I could shrink it with smaller profiles. Like I can use, you can get 10 millimeter rails, but man, that's getting flexible at that point. 10 millimeter rails are not nearly as stiff as 20 millimeter rails. Do they make 10 by 20 extrusion? They do make 10 by 20 extrusion. It's literally basically half. So there's your standard 2020. I don't see any 1020. Let's check Amazon first. That 80-20 is nice. That would be nice for the Z-axis. 2 linear rails directly onto an 80-20. That would work pretty well. That would work really well, actually. How about if I just do a search for 10 millimeter extrusion? Here's 10 by 10. I could order a piece of 10 by 10 and then see how strong it is. I'm just not sure if that's stiff enough. You know, it's only 12 bucks. I'm just going to grab one. I can afford that. Plus, it would make great launch rails for rockets. Okay, so that'll be here Saturday. And here's a, oh, there you go, 1500 millimeter. How long is 1500 millimeter? 15, it would be 60 inches long, so 5 feet. That would actually make a really good launch rail for a tiny model rocket. That would make a great micro launch rail. I'm going to save that. That's expensive as all hell, but that would make a, you'd only have to buy one. That would make a great launch rail for Micromax rockets. Because 5 feet is more than enough. Heck, cut it in half and you got 2. That looks like 2020. Okay, so we're going to get some 1010 in. See how strong it is. See if it's strong enough for what we need. It might not be. Because I don't care about weight. Weight doesn't matter. Yeah, the problem is linear rails might not be small enough. Ow. Yeah, they're all going to be based around 20 millimeter. I suspect. Yeah, I suspect most of these linear rails are going to be based around 20 millimeter rails. Well, let's put in, see if anything comes up. I suspect we're going to have to increase it. Probably make it like... Damn. I'm really trying to get as close to 2x2 as I can. Might have to go with the bed slinger. I should be able to easily do it with a bed slinger. But I was trying to go with that cube for easy transport. You know, something that could maybe survive in your luggage on an airplane. An Ender 2 would never survive in luggage on an airplane without some pretty hefty packaging. Yeah. I gotta think about it. If you guys have any ideas, let me know. But I gotta think about that. I gotta think about a way to do that. And that means I'm gonna have to make the X carriage plate as compact as possible as well. Because if that sticks out too far, that's going to increase your buffer space that you need to allow that nozzle tip to reach the edge of the bed. So I'm probably going to be better off sticking with an Ender 2 King Rune style construction, and then just shave off as much from the edges of it as I can. Shave off as much from it as I can. So, for example, being a bed slinger that takes care of your y-axis dimension, and that allows me to use space on the X carriage to compensate for XY or Y dimension or X dimension. What else? I gotta work on it. I gotta work on different ideas. I was also thinking about, I don't know how practical it is, but I was thinking about a linear rail for the y-axis. And I was thinking about a double belt system, top and bottom belts, to even out the forces. But I don't think that matters once you're a linear rail. I think the stiffness and the tolerances of the linear rail take care of that. So it's okay to have a little bit of offset pressure from the belts, so we don't need to overcomplicate. Especially because we know an Ender 2 works great. Gotta think about that. Gotta think about that. Because I want to use this machine to go to 500 degrees. One of the reasons I want to make it so small, and one of the reasons I want to make it so I can put an enclosure around it, is because I want to do high temperature with this machine. I want to print peak on it. Maybe that's crazy, maybe that's dumb, but I want to. I want a machine capable of doing that. And
especially now that we have a 500-degree hot end that's capable of 500 degrees for 50 bucks. You know, that makes it feasible. You know, I would start off with a regular Ender hot end because I already have them, and then once the printer's done, then I would buy one of these. Yeah, interesting. All right, I'm going to scat. I'm going to go run to the post office, start thinking about dinner, and go from there. So I will see you guys later. I think next week we might try playing with the new laser, the new Ray 5 that I got from Longer. I think I might want to play with that next week. And go from there. But yeah, I want to do something with this. I want to try how compact can we make a truly good printer. I think I have to go with a bed slinger at first, especially since I could repurpose almost everything from an Ender 2, which will allow me to get a prototype built faster. Just have to buy some linear rails, some design a new hot end, stuff like that. I gotta look into. I'd like to get a better. Is there some place where you can buy these hotbeds, these heat plates? I'd like to get like a 4 or 5 millimeter thick heated bed, something better than what these printers typically come with. Although I'll be using a 0.6 millimeter nozzle for most of it, so the tolerances built into these cheaper beds is good enough for that. Although I'd like to bump up to 24 volt. Just for the faster heat up, faster go. Although I like the 12 volts for portability, because the 12 volt means I can run directly off of solar and batteries. So for a printer this small, 12 volt is actually kind of advantageous. With the 24 volt, you have to use a power supply, and that means you also have to use an AC inverter. So you're going to have efficiency losses in the power supply and efficiency losses in the inverter, which adds up to quite a bit. So I would love to stick with 12 volts if I could. I wonder. I guess that wouldn't work. Is there a way to direct, to basically do a mains powered heat bed but 12 volts? So instead of running it through the power supply, run it directly off of whatever your power source is, and then use the, you know, the, what's the gadget in the, it's like a relay, the solid state relay that they use to control, you know, turning it on and off. It's probably too much of a pain. It's the efficiency losses aren't that great. Go from there though, but yeah, I wonder how, you know, how much can I improve the Ender 2? So maybe start with that. Start with the Ender 2 and see how much can I improve it, how much can I make it better, and go from there. All right, I will see you guys later. You guys have a great day. Thank you very much for joining in on my stream. I appreciate that again. Thank you to all my Patreons who continue to stick with me and be loyal. I really, there's nothing to say. It's beyond my mind how incredible that loyalty is. I appreciate that. So, I will see you guys later. And I'll go annoy him now. Thank you very much again. You guys have a great day.